Jack it up.
It's 9 now. Shall we start?
Give me another 5 minutes, Dr. Yong.
Sorry?
Give me another 5 minutes.
Okay, sure.
Our world is transforming, going through a revolution that would significantly change the way we live. The fourth industrial revolution is at full speed, and this revolution allows for endless creation and innovation. Are you ready to take on this revolution? Kismek, since its inception in 1993, is a leader in TVET and human capital development. We are also internationally accredited and globally recognized as an Industry 4.0 training provider. In July 2017, Kismek was accredited as a Center of Excellence in Technology COE for national empowerment in certification and training for next generation workers, NextGen Industry 4.0. Here is our roadmap of Industry 4.0. We are here to be your partner in this challenging yet exciting era of Industry 4.0.
We focus on technical and vocational education training, or TVET, and strive to deliver the best in Industry 4.0 training, which means progressing with time and technologies. Kismek has invested in new training equipment and machineries such as APAS Collaborative Robot, Bosch Didactic Workbench, Festo MPS I 4.0, IoT Gateway, Bosch Smart Sensor, and Smart CCTV. We have upgraded our trainer skills and our center certification. Currently, our trainers have been certified as Malaysian Meister Trainer from Aachen, Germany, and Bosch trained the trainer in Basic Automation Industry 4. To complement industrial requirements, we shall continuously develop new training programs.
With strategic partnerships and collaboration across the globe, Kismek offers a wide range of training programs conducted by our very own highly qualified trainers in various fields of expertise. We continuously strive to be the preferred training partner by developing new training programs and upskilling of our certified trainers.
Okay, Amiro.
These are certified and experts in their respective.
Okay, Dr. Lee. Dr. Yong and Dr. Lee, yeah, take it on from here.
Yeah. Also, have you pressed the record?
Yeah, it's recording, yeah.
Okay, thank you. Yeah, Dr. Prof.
Good morning, everyone. Welcome to Industry 4.0 Technology Week 2021. I would like to share my slides. Thank you. Wait for a moment. Okay, this Industrial 4.0 Technology Week are organized and participated by MITI and MOSTI, EEPN initiative, all the Technology and Experience Center, also the University Center of Excellence and Industrial Engagement. These are all the lists. Today, this 4.0 Technology Week has 7 sessions. Today is session number 5, which is University COE and Industrial Engagement. And universities had its own strength to supplement or to complement, okay, the industry in terms of research and development, especially proof of concept development. So we need, Malaysia is a small country, so we need university, industry, and government agency together to push Industry 4.0, okay, in Malaysia. So that's the reason why we have a session number 5 and number 6. Now today's session number 5, we have 4 institutions of higher learning in Malaysia. The first one is UMP. The second one will be the TAIUC, which is Wadu Rahman University College. Next one is UM, which is Malaysia. The fourth one is UTEM, Canada. Okay, UTEM. So these are all the speakers for today's and the topics. The first one here is from UMP. Altogether got 4 topics here. And the first one here is a pick and load omnidirectional forklift by Associate Professor Dr. Adi Iwan Hashim. The second topic here is fiber brake grating measurement systems by Associate Professor IR Dr. Muhammad Hafizi Johari. The third one is intelligent solar powered irrigation systems by Associate Professor Dr. Muhammad Safi Najib. Last one is infant for environmental safety and monitoring by Dr. Fashariza Ramli. Okay, so this is 9 to 10:30. Then we have a break, and then we continue again from 11 a.m., which is from IUC. I'm the one, Dr. Lee Waping here, to give a talk on the individualized manufacturing solution with Brahmi 4.0 architecture. Half an hour later will be by UM, CRI 4.0 Center Technology, remote access monitoring with RFID and a GPS system by Dr. Hari Krishnan Ramnia from 11:30. Then finally will be the UTEM. Topic is a simulation optimization as a tool for IR 4.0, machine controller design for precise and accurate positioning in machining process by Dr. Muhammad Najib and Professor Dr. Zambili, okay, from 12. Then we end the day. Okay, so these are the background of all the speakers for today. I'm not going to read out, so I just screen through. Okay, Associate Professor Dr. Muhammad Safri, Dr. Rosaliza Ramli. Okay, sorry, is missing. First one is Associate Professor Dr. Adi Iwan. Second, Associate Professor Dr. Muhammad Hafizi, okay, background. And Associate Professor Dr. Muhammad Safi Najib. This one I mentioned just now. Then this is my biography, Dr. Lee Waping. This is Dr. Hari Krishnan Ramia. Finally will be Dr. Muhammad Najib Ali Mokhtar. Last one, UTEM. And then the other one here is Professor Dr. Zambri Amaluddin. Okay, so if you have you want to join the rest of the sessions here, you can get information from here. Okay, so these sessions here will allow the speaker to speak according to the time allocated. After that, we are going to have a question and answer from the participants, and then we will follow by the next topics. Okay, thank you. So without any delay, I would like to pass the floor to UMP. Thank you. Yeah. Dr. Adi, thank you. Yeah.
Can you see the slide?
Yeah, sure, no problem, can see.
Okay, can I start?
Right. Yeah, sure.
Okay, Assalamualaikum and very good morning to all the participants and viewers. So for this slot, I would like to share about one of my projects with industries that related to the robotics into industries. Okay, so for this today's presentation, so I will give some overview regarding the products that I have developed with the company named as Vacuum Schmeiser from Germany. Okay, so this system we call that a pick and loaded omnidirectional forklift. Okay. Okay, this project is actually, I go through the introduction at first. It's actually come from the ideas, the first ideas that the VAC or Vexumizer would like to have a very small forklift, which is not available at that time in market. And this small forklift, they need to have a capability to pick up the quite heavy copper spool, which is their raw materials, which is about 30 to 50 kilograms. So from this idea, Mr. Arif, the boss there, called me for the collaborations, and we team up to sub group, which is one is electrical, one is a mechanical group, which is handled by my partner, is by our Dr. Akhtar below there, mechanical engineering consultant, and supported by their field engineers, Mr. Sheikh. Okay, so we generally, the close of the project, we start with the capstone project from the students, and then we enhance in the internships program with the VAC, and then we continue into the final project. So in this project, we focus on the problem statements on their warehouse, which is they have a very confined warehouse. Because these products, we focus on the confined area, which is about 1.7 meters square. And then the current warehouse is getting confined because of the limitation of the place. Okay. So the target is kind of you can see here is this very confined area, which is the current situation in VAC also is getting packed and getting confined every several years. Okay? Because of the area that they have is not enough for the storage. Okay, so for this, the first phase, in the first phase, actually this project is the first phase of the project, because after this we have a continuous project in the second phase. Okay, in this first phase, we target for the inventory rack is about that dimensions, and we need to have a system that can pick and load inside the vehicles, not carry on with the vehicles. So that's the main idea and the main target for this project. Okay, so and then we would like to bring these systems, these vehicles remotely, not manually pull the vehicles. Like currently they're using the operators just using the pulley, which is quite difficult and heavy and very consume time. Okay, so in this development phase, in first phase of the project, we have developed a start from the conceptual design and first model, and then until the final model. So in terms of mechanical and mechanisms, we have a design to fabricate two models, which is the first models without the suspension, as you can see in the slides, and the final model we have a suspension because of the factor of the mechanism wheel that we need to have overall touching on the floor. Okay, so and then also we have another problem with the inventory rack that currently change because of the stack change according to the countries. Okay, right. All right. For electronics, we basically we have a very basic driver for the heavy torque motors, and also for the linear guide drivers. Okay, and we also have real-time viewers from the remote control, so that the users can see from the camera to slot the heavy spool inside the rack. Okay. All right. So the comparison from us compared to the marketable partly, which is we have the loading as mechanism if compared to the market, which is they only have external port lister, so they need to bring the load with them, not loading inside. So they kind of cost the space for the vacuumizer situation. All right, so this one is our patent site and the publication of this prototype. All right, so this is a problem, which is when our first deployment on the final stage, sorry, on the first model. Okay, we have difficulty to view. We have difficulty to align the grasper, the lifter, according to the rack, because the rack is changes because of the countries. The wood rack is actually come with the copper spool. Okay, so from there we change to the second to the final model, which is we add the height of the port leaf, and we add the spring absorbance for the port leaf, so that the wheel can overall touch the floor, which is we find that some floor is uneven. Okay, so and then the current situation, as you can see for the second videos, it's getting confined, and we need to do some improvement according to the speed, and also the viewing side, as well as we try to add some autonomous element on the second phase. All right, so for commercialize, actually these system or these structures can be redesigned for any skills that required based on the customers, and can be reconstruct or retrofit with the IoT system and autonomous element for some applications, including the medical logistics or pharmaceutical logistics, as well as this farming, and also you can use for the office or classes assistance. Okay, I think that's all for my presentations. Thank you very much.
Thank you. Thank you, Associate Professor Dr. Pati Irawan. Very interesting project. May I have any question from the participants?
Yeah, this is Fauzan. Thank you, Dr. Adi.
Yeah.
My question is related to the battery and the weight and the navigation. Is there an optimization algorithm how to have a longer battery life, or how to save energy in your part of your scope?
Currently, we are not focusing on the situation, because on the first phase, according to the first phase, we only concentrate on the operation, the basic operation of the system, and then meet the requirement of the industry, because they want to use it in the store. But for the second phase, we will consider on the battery or energy efficiency, as you said just now, because that one also quite critical when we apply the autonomous operation afterwards.
Because some of the design AGVs have a self-charging mechanism. At rest, it goes back to a location to get charged. So in this operation, I think you haven't considered those smartness.
Not yet.
Okay.
because that one is considered as the autonomous part. So we need to finish up the mechanical and electronics remotely controlled part only, because the first requirement from the we can say that back is our client. They only want the remotely controlled, and then afterward we work out on the situation. We actually realized that they have some technology.
How many prototype was built in the first attempt?
The first attempt only one, because they only needs one currently.
Okay, and they are happy with the current design. They want to put additional units.
Yeah, yeah. Maybe on the next phase, they want put some cosmetic part there on the casing, so that.
Okay,
Mhm.
aesthetic improvement.
Yeah, yeah, yeah.
Okay, yeah, thank you.
Thank you very much.
Thank you. Question from Thousand. Next question from Miss Dr. Yung Mimos. Question is the forklift able to address the height requirement?
The height requirements. What do you mean by?
Meaning that how high it can go up and down?
Yeah, actually, we designed this one for only two level of the rack. But as I said just now, all the automatic is not yet there. We just operate in manually using remote control. So maybe afterwards we add a little bit autonomous elements and automatic elements to improve the situation. So at that time, it's not crucial for the client.
Okay, thank you. Any question from the floor? If not, I have two questions. The first one here is what is the speed of the vehicle, and how to taking care of the safety, because speed killer. Thank you. First question.
I just forget about the speed. For the speed, it's actually we can go. So for the speed, actually, we can go about 70 meters per minute. Maximums, we can go about 600 RPM, but that one is depends on the button, because we have a button to regulate the speed. But currently, we have a feedback from the client that we need to have some system that can we regulate on the screen on the top of the vehicles. So we will take that response to improve in this semester. I hope that.
Thank you. Thank you. The second question. This machines, this prototype is automatic guided, auto guided.
Yeah, I'm sorry.
Auto guided. Is it auto guided machines? Or
No, it's a remotely control.
Oh, remote control.
Mm-hmm.
Thank you.
It based on client requirement at that time. So enough for remotely control, they say.
Okay. Thank you. Good.
Yeah.
Good, Jackson. Okay, so these are all the questions. Anyone want to ask questions from the floor? If no, thank you. Thank you very much.
Thank you,
Dr. Professor Dr. Adi. So we go to the next topics by Associate Professor Dr. Muhammad Hafizi. Thank you. Yeah, the floor is yours.
Okay. Yes. Okay. Can you hear me?
Yeah, loud and clear.
Okay. Thank you.
Loud and clear.
All right. So, Assalamualaikum and good morning. Thank you. I've been delighted to be here to present my work and my project. This is actually a 7 years project, starting from my beginning of my PhD. So at the end of I filing up this patent for my project. Name is fiber rating measurement system. So this slide, I will bring you to a journey of learning what is actually fiber rating measurement system. Okay, actually, large structural background, large engineering structures like bridges, buildings, oil and gas pipelines, dam, airplane, aerospace vehicle, all need continuous monitoring. But however, these massive numbers of sensors require a lot of cabling, require a lot of also sensors itself and data acquisition. So it's gonna be very messy, and sometimes it's add more weight. For example, for airplane, it costs massive weight. Therefore, nowadays they are turning into fiber optic cable sensors, which is a specific fiber rating sensor. So, but however, the fiber rating sensor have actually the fiber rating sensor, it solves a lot of weaknesses experienced by conventional electrical based sensor, for example, strain gauge and piezoelectric sensor. The weakness is such as sensor mounting, electromagnetic disturbance, massive cabling, as I mentioned just now, for very long distance monitoring or for large structures. If you see the picture that I share, as you see the difference between massive cabling for the conventional copper wires compared to the fiber optic cable. We only have one line, a very small line. You can imagine that even if you see your Unify cable, the same like that, the same application, the same cable, it will contain information, infinite information, just only for one cable. The realization of FP sensor system for monitoring of the structures is completed by our introduction of our product, which is an all-in-one compact FPG measurement system. You can see through the pictures. There is a lot of versions for the system. So let me bring you to the problem statement. So currently, as mentioned just now, currently the piezoelectric strain gauge, they have a problem, just mentioned just now. By turning into the optical sensors, you can see the market value. If you use the optical sensors, it grown every year. It started from if you see from the year 2020, USD 1.5 billion. Now they predicted that this value for the optical sensors become 2.9 billion by 2025. So if we don't involve in this industry with the involving optical fiber, I think we are going to be behind with the risk of having a very compact measurement system. Or in our nowadays we are talking about distributed sensors, more sensors in our structures and in our whatever that engineering structures that we have. So this is what if you see the infographic of my invention, this is actually an all-in-one box for the fiber measurement system, and it's applied to any structures. Just connect to all the surrounding of the structures, and then you connect to this little box, and then you can see the software or the graphical user interface showing the real time of whatever happened to the structures that we measure. So the IR 4.0 element, just I want to stress out this one. So this product support the fourth industrial revolution, whereby it offers the like I said, distributed sensor system, so that the sensor system will provide us a real-time monitoring, and then we can collect the real big data for all the structures that we measure, for future development and also for the safety purpose. So imagine that we have like this, we have bridges and we have infinites. Let's say we have 100 FPG sensors mounting on whatever section that we want to measure. So it can connect directly to our measurement system. Okay. So this is what I just mentioned just now, the distributed sensor network. So with this fiber optic sensor, we can connect all the sensors in series, in array. We mentioned this in FP sensor array, so that all the informations can directly go to the measurement system through the multiplexing. So you see this video. So let's say we have multiplex sensors, and then we have a heat moving to this the colors wavelength refers to the information that we receive. So we can see this information in real time. So I would like to show you another example of what we do. So this is a car on a bridge. So you can see it from the software, it's in real time showing this information. Either we can see from the weight of the vehicle, the size of the vehicle, and then the vibration as well. So there's a lot of information can be collected by using the system. But only using this example I'm showing about one sensor only. Imagine that we have 100 sensors. We can see all the information through the sensors. So the potential users for the system is the Jabatan Kerja Raya, for the maintenance of the buildings, the highways management, the dam. We have a lot of dam, and then we have also we have chemical plants, Petronas and Shell and so on, and then we have all these pipelines, chemicals plants. We also can use the system to monitor the structures, the safety of the structure as well. There's a lot of engineering applications out there in worldwide. We have bridges already done in Portugal. We have a lot of monitoring using FPG sensors. Portugal, the Hong Kong, and we have also in railways in Italy. We have in China. We have monitoring for pipelines. Also, we have the system to monitor the concrete. Pre-stressed high strength concrete during the development, the manufacturing, and then we have oil and gas casing pipe, and this is actually what we have already not ours. It's actually what already done by others using the sensors. But we in UMP, I built the reader with the system that can read the information from the sensor. So I patented this system, okay, under the two patents. First is online impact damage monitoring, and the second one is apparatus to monitor static and dynamic signals. Okay, and it is my collaborations. I have collaboration with KPT, Kementerian Pendidikan Tinggi, and also UMP and UMP Technology, and my partners, Photonic Research Center, and my clients, Petronas, UTP. And then also we have other clients is University Kebangsaan Malaysia. So that's all my presentation about the system. So thank you very much. I hope that I can give you an insight of what is a fiber grading measurement system. Thank you very much.
Okay, thank you, Associate Professor Dr. Muhammad Hafizi. Short and precise. Good project anyway. Very good project. There are a few questions posted by the participants. I read it out, then you answer one by one.
Okay.
The first one here is from Dr. Yong again, Memos. How the fiber grading measurement systems address false signals, both false positive and negative.
Oh, it's actually depend on the strain. If the force is I think this actually about the physics of the system sensor itself. If you stretch the sensor, it will give force, positive force. If you compress the sensor, it will give negative force. I think if you see from my slide just now, I think it's actually showing this one. you can see the graph. You can see the this is actually about the compressor. When you have weight, it will give a stretch through that direction, so it will give a positive value. But if it's compressed, it will give another directions to the. So you can see actually it's directional. Actually the sensor is directional. Yeah.
Yeah. Thank you for your answer. So, Dr. Yong, do you want to? Is the answer satisfied your question?
Yeah, please.
Okay, thank you, Doc. Basically, I'm just curious. Like, every technologies, there is a tendency that the signal that we receive have apa tu their credibility of the signal. So I'm just wondering, because the fiber optic sensing, because it's a distributed and then it cover quite a length, quite a large length in terms of the coverage. So how do we differentiate by the whether like the car, I mean when the car moved across the bridge, whether that is caused that signal that we receive give the structural management that is worth for any intervention action. That is my question. I think just like what Prof you have said, like basically there is when there is a distinctive characteristic between the positive and the negative. I think that would be, is that perhaps a very low layman question is like, is that the common industry practices for the fiber optic sensing industry?
Yes. Actually, there is a lot of application for this one. Actually, not only measure the strain. This one, what you mentioned just is just a direct strain, which is like a strain gauge. You have different directions, different. We have directional, and we have amplitude of the force. Okay, so it can be done the same as with this fiber bracketting, because you can imagine it's the same. If I mention a strain gauge to the industrial player, they will know what the actually how it works. And then just imagine that the strain gauge is electrical based, this fiber bracketting is optical based. That's the only difference.
Okay, thank you, Prof. I think my last question is basically is like, I think there is a limitation for the length for the for fiber sensor system. So what is Prof your system able to cover? How long? What is the length max that your system will be able to cover? Thank you.
According to literature, the fiber optic, the lights can travel in fiber optics about 1,000 kilometer. But that one, they didn't calculate about the attenuation of the signal. But for my system, 1 kilometer, I think 1 kilometer length, it should be enough for to measure the whole. We have plants, and we have dam. Okay, and railways, because usually when we use the system, we're not going to use one system for the whole structures. We might need to have in some we call it some station. Let's say for 1 kilometer, we have one station to measure the whole kilometer, and then that's what usually we do for better management of the signals, and also the information that we get. We're not using one system, the whole structures. It's actually not safe. Not safe for the information that we get.
Okay, thank you for question from Dr. Yong and answer. Next question here is from Noyati Mohammed. Yeah. So question is, how is the real-time data store? Is the equipment attached with any cloud platform or database storage?
Okay, thank you. This is actually a frequent question by the industry about this one. Either we just can get the real time and just simply release the information and through radar or through the internet, and then there is another receiver anywhere else in them all over the world or in Malaysia, and then they store the information there. For example, we have pipelines in a rural area for example, in Sarawak. There's a pipeline rural area in Sarawak. So the information from here, we release the information directly to the through the internet, whatever system, and then received by any other receiver, maybe from KL, from Kelantan, or in Selangor. And then this one other method. We also can store the system in the box using local hardware, local drives. Also can be done with that. But for the optimization of the data, we need to pre-process the information first. We're not going to save the raw data, otherwise it will cost storage. So if we need to pre-process data, that one will cost these powers to process data. So we need to have optimization between the powers and also the storage. So if you want to minimize the powers, let's say we put it in the rural area, we need to transfer the data somewhere else. We do post-processing in somewhere else. But we can do both. It's because it's actually the most important is this the house sensor, how we convert the light from the information sensor to the electrical signals that we can get from the box. That's only important. That's only the invention that we do for this box. The storage wise, I think the one can be done in many ways actually.
Thank you. Thank you. Question answer from Dr. Muhammad Hafizi. One more question from the floor by Fosen Press. How much Industry 4.0 technology is being used in civil engineering, construction industry, and what are the potentials?
Okay, globally, I can say.
I want to add in also for security also. For example, like the safety community, gated other houses. Can it apply in that kind of environment?
Sure. Okay. First question about the how they use this one. I think globally, like the picture I just shown just now. Globally, in China, in Italy, in Portugal, in US, they are already done. Even especially in US, they have a lot of patents about this product, about this the way how they use fiber braiding or optical sensors. In Malaysia, I think not many people have done. Through my experience with this system in Malaysia, these 10 years I've been here in Malaysia, I think there's not many people have using this one. It's actually very new in Malaysia. Okay, so basically, if we didn't use this one, we will be ketinggalan. About safety, yes, we can actually use the same cable, that unified cable. Okay, you use the same unified cable. In fact, I can use my cable unified here in our house to connect with this one, and then put the sensors in anywhere I want to. Let's say I want to measure the water tank on the top of the ceiling. The height of the water, I can also measure with this one, connect to this box, and a lot of things.
Okay, thank you for your answer. Last question. Okay, last question for me, for myself. Because when you're talking about measurement systems, actually the natural question will come. How about calibration?
Yeah. Good question. I think this is actually what we've done every day in our lab. Every time we use sensors, we will calibrate sensors, and then the sensitivity will be as the I think the most important for the sensor is the sensitivity. For the system, as long as we give the sensitivity of the sensors, the system can convert into the correct information. Okay, so the most important is the sensitivity on the sensors. If you purchase sensors from anywhere, it will give the sensitivity value. I think any sensors, because these fiber bracket sensors, either you can buy a complete sensors from the manufacturers, they will give you the sensitivity value, or you can use your own fiber and make it as a sensor. That one you have to test in the lab and then get the value for sensitivity. But for the general sensitivity, 1.2 picometer per microstrain. Actually, this one is established numbers, 1.2 up to 1.1 picometer per microstrain. I think this is the general sensitivity value for the system.
Any standards? Any standards for this sensors measurement system? Standards.
Okay. Standards. Standards actually depends on the measure.
International standards.
International
Because you are
standard.
using because you are using in the aircraft, you know, in this building, multi-story buildings.
Mhm.
So do you have any international standards, you know, for these sensors?
Okay. Basically, I haven't found any standard for this one. Basically, usually, when I deal with this one, I didn't deal with the standards. I deal with the safety. I mean, the, let's say, explosion proof and so on. That one, I think they're looking for that one more important. But the standards, actually, I haven't found any for the standard. Maybe they have ASTM for optical sensors, but I haven't found any specific for these sensors to be used in any in the application for civil. And maybe after this I will have a look at this question, and then let's see. I will look for the standards. I think I will get more frequent question about this one.
Okay.
Thank you.
you.
For the questions.
Yeah. So I think this is the last question.
Yeah.
Thank you very much, Associate Professors Dr. Muhammad Hafizi, for very interesting topics here. Thank you very much.
Thank you.
So
Thank
now
you.
we move into the next topics from UMP by Associate Professor Dr. Muhammad Safi. Yeah, pass it to you. Thank you. Topics is an intelligent solar power irrigation systems. Thank you.
Sorry, Prof, it's supposedly this topic. E-Unfun.
Okay. Okay, so means topic number 4. Number 3, the third topics by
You switch between Dr. Rose and Dr. Shafi.
okay. Yeah, so I apologize for that. Okay, so you can go ahead. Yeah. Thank you. You can go ahead. So the third topics is E-Infant for environmental safety and monitoring from Associate Professor Dr. Muhammad Safi. Okay, so you can proceed. Thank you. Cannot hear you. Cannot hear you. Your mic. Dr. Muhammad Safi. Your mic. Can't hear you.
We can't hear you, Doctor.
Yeah, I can hear you.
Can you fix your microphone?
Yeah.
Okay, Ilma? Ilma?
Yes. Kejap.
Yeah, we don't have a sound from, yeah.
The mic is open. Prof, can you share again your screen?
From the control here, we can see you're unmuted, but your voice is not being picked up. So now, okay, now you're unmuted. It's green, but we don't hear you. Maybe your audio device need to be configured. Ataupun we switch to Dr. Rose first, and then we come back to Dr. Sharfi.
Dr. Rose, can we proceed with Dr. Rose first?
Yes, sure.
Okay, all right. So, Ms. Dr. Lee, let's introduce Dr. Rose. We'll come to Dr. Sharfi after this.
Yeah. So, Dr. Rose, Rosa Selina, topic is
Roshaliza.
yeah, you can proceed. Topic: an intelligent solar power irrigation system. Okay, pass it to you.
I share my slide.
Yeah, you share a slide.
Do my screen appear to everyone?
Yeah, loud and clear.
Yeah, we can see your slides.
Right. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good morning to all participant and audience. I'm Roshaliza from Faculty of Electrical and Electronic Engineering Technology, University Malaysia Pahang. So this morning I will present my innovation called Portable Intelligent Solar Irrigation System. Okay. Right. So irrigation is one of the important elements in agriculture. There are several methods to use water as irrigation, and one of them using water pump. However, most farms use diesels, powered water pump, or fossil fuels powered water pump, which is quite expensive for longer use and not environmentally friendly. So even though there are several current technologies focusing on smart farming or smart agriculture that have been introduced to our local farmers and planters, they are mostly focusing on the large farms with the help of fixed system at site. Therefore, it is expensive for the small and medium farm owners to own a smart system that could help them manage their farms. And if they could not afford to have such technology in their farms, they have to hire more workers that demanding higher wages, which could increase the operational costs. So weather and climate are among the crucial factors in agriculture. Too little rain, your crops dies. Too much rains, your crop dies too. So in 2017, Pahang and some other states in Malaysia faced severe drought, which affected the productivity of farming and plantations. So I actually saw with my own eyes, and from some quick conversation with several farmers on the way to and back from work, on their struggles in producing the crops and selling them. Then when the raining season come, they were also worried because of the flood that again affected their crops production. So by having portable irrigation system, they somehow can store it in safer place during the flood season and then reuse again when the flood receded. So I came up with an idea to build a portable system to help farmers in irrigating their farms. So my product, this is my product, Portable Intelligent Solar Irrigation System, or actually I call it as ISERS, that powered by 3M elements: mobility, modern technology, and modularity. So it is cost saving and also could supply cleaner water to the crops. So this product actually has been filed for Malaysia patent in 2020 and has been given a patent application number. So this is actually some videos, some demonstration videos that actually I prepared with my students to show the functionality of the product. And as you can see here, it actually uses PV panels that can be flipped, all right? And then because of the most electrical water pump use electricity to operate, it is quite difficult to use this product at the farm with no electrical power supply, which most of the farms or planting area is actually far from the electrical grid. And then the ICES also use solar energy as power supply, and then use mobile apps as remote controller, as well as monitoring system. So this product has two PV photovoltaic panels that can be flipped for storage. And then during operation, the solar panel can be expanded and tilted to a position in order to obtain maximum sun exposure. And then ICES is also equipped with a battery, a backup battery that can be powered when we don't have enough sunlight. So the operation of our product can be done remotely using a smartphone via mobile apps that actually my students develop. Using this mobile application, the user or farmer can monitor surrounding environment based on the environmental sensors installed to the product, and it can be customized based on the farmer needs. The users do not have to worry to leave their home or farm because it has been taken care by our product, and it can be operated and monitored anywhere. We also install a water filter inside the ICES to increase the water quality to the farm so that it can help supplying cleaner water source for better growth of the crops. So we provide on-the-shelf product that can be used with any type of irrigation such as sprinkler, water drip system, and compatible with any type of hose nozzles. This shows that our product is portable to be operated anywhere, anytime. So we have tested the product at UMP pilot fertigation farm in Gambang, Kuantan, to get several data on site on its functionality and performance. We also did some surveys with the farm manager on the product, whether it can be improved and other features could be added to the product. Then we also integrated the product with the watering drip system we developed at our MOOC pre-nursery site in the faculty for the industrial collaboration project. So last year, in 2020, we have filed a patent application in Malaysia and pending for approval. The product uses multiple sensors on perception layer together with water pump and battery management system. Then those systems are linked to the server at the network layer before connecting to application layer via a smartphone. So far, we have received several recognitions from the exhibition we participated before. Actually, in 2018, we developed the proof of concept prototype before come out with this product and presented the idea at International Warsaw Invention Show 2019 and received a bronze medal. Then after we completed the product in 2019, we participated in International Invention, Innovation and Technology Exhibition Malaysia, ITEX 2020, and received a silver medal. Earlier this year, in July, we also presented this product at the MyTech Pitch event organized by Mosti, and we received a lot of interest from the industry players and inventors. So we also actually have secured a matching grant with YP Plantation Holdings in developing a solar irrigation system for oil palm pre-nursery at Rompain, Pahang. So other than this, we also engaging with local farmers around Kuantan and Raub currently in helping them with the irrigation solution. So currently, we are collaborating with two industry partners, a palm oil company, YP Plantation Holdings in Berhad. This is a company under Yayasan Pahang subsidiary, and also Singularity Aerotech Asia in Berhad, an engineering and technology solution company. So these collaborations would actually support us in developing and enhancing the practicality of the product and also perhaps future projects. And last month, UMP and Singularity Aerotech Asia just signed an MOU on virtual signing ceremony to explain the collaboration beyond research, mostly related to graduate employability and training programs. So the further work that we're going to to do after this is to conduct more real site testing for market validation, integrating with other sensors that are crucial for agriculture, work on more efficient methods in communication and control system, and as well as developing more user-friendly interface for the farmers to use and understand how to use it. So this is my team members working on this prototype and also industrial grant projects under our own Smart Agrotech UMP cluster. We are also involving some students, mainly from undergraduate final year project, in helping us with the project we are currently working on. So I think that is the end of my presentation. I can be contacted via phone and emails for further discussion and collaboration. So thank you for your kind intention. Okay, back to you, Dr. Lee.
Thank you. Thank you, Dr. Rosalisa. Very interesting project, very practical. Now there are a few questions from the ground. The first one from Fauzan Nasir, Press. How is the take-up rate by the agriculture sector on your solar power portable irrigation system?
Sorry, what pick-up rate?
Meaning that adoption meaning that
I see.
Yeah.
Okay, because after this product is actually not well promoted, I would say. So, but after we participated the MOSTI event in July, we actually got some feedback, mainly from local farmers, especially in Rao. They actually contacted one of our member on this product and asking for demonstration. But because of the PKP MCO, so we couldn't move around Pahang, only in Kuantan, so it's quite difficult for us to demonstrate. But we are going, we are trying to be more proactive after this, and then try to see how our product can help the small and medium farmers to at least help them with the irrigation solution. Currently, actually, we have some collaboration with the SET Asia, Singularity Asia Neighborhood, and they actually have some difficulties or issues in R&D with their products as well, and also their solutions that need our help. So it's actually a good thing to explore lah, because I think smart agriculture is getting more having more attention from the farmers to use the smart system. But as I said earlier, it's quite costly for the fixed system to be installed at their farm, as well as if they only have not that large area to manage, it's quite costly lah. So my solution is having this product to help them, and if they want to integrate using multiple products of my products, we also can help them to do that rather than having the fixed system on site. Yes.
Thank you. Second question. Next question. Any other projects doing in UMP other than this project? Do you have any other projects?
I know that there are some projects in fishery, but I'm not quite sure. But as for my team, we actually focusing on this agriculture, more on the irrigation currently, and working on the fertigation after this. But we try to see if we can help the small medium farmers or enterprise farmers or planters that might be having some issues in financials. So I'm not quite sure in UMP who actually doing this, but there are some researchers in UMP doing research in agriculture as well, but mainly in chemical-based research. Yes.
Okay, thank you. Next question. If you charge charge it using the solar power, how long it can operate for the system?
Okay. Actually, our product is actually working in two ways. One is directly getting the power supply from solar panel. Another one is from the battery. So either if you are not using or you are not operating the product, the product still can get the solar energy and charge the battery to be used later on. So when we charge it, if we are using it directly from the solar panel, it doesn't have to be how long, as long as there are sunlight. But if there are no sunlight, the backup battery will work on it. And as for our findings from the functionality test, the battery can long up to 3 to 4 hours. So after the full charge, so it might be changing towards time, but we are going to try to develop or improve it towards time as well.
Thank you. Next question from Dr. Azim Afro. What is the uniqueness of your products compared to others? In a small agriculture, this system seems to have become a standard. Can you explain in detail what is the strength of your products?
I'm not sure about the standard because I'm still working on this, and we are trying to improve it towards time and make it more compact and portable and hopefully light enough for the farmers to bring around their farms. But I'm not sure about the national standard or international standard, but we are trying to fit or adjust the product to be exactly what the standard wants. So the uniqueness would be the small or compact or portability. This product can help the small or medium farmers to use, and the simpleness without having to know to connect this and that. It can be plugged in methods when they want to use it at the farm. So I would say that the uniqueness I would say from my product, the small, compact, and simpleness to be used by the farmers who maybe not having who are not tech savvy enough to use modern technology. Yes.
Okay, thank you for your answer. One more question. How, from the Dr. Yung again, how the energy load balancing and optimization work for your systems?
I haven't gone through that yet. It's still under consideration and research. But so far, the product is operating good enough to supply the water to the water pump, the solar panel, the battery, the control system, the communication system is actually working well together. And we need to see each part of it to see either there are some, like you say, the stability of the energy that we try to get from the solar panel and distribute to all the components that we need to use inside the product. So as for about almost 1.5 years through this pandemic, development of this product is actually getting slower, but we hope that after this we can speed it up because I can see that some of the local farmers really want to try this instead of doing all the irrigation work manually. So I hope that answer Dr. Yong's questions.
Okay, thank you very much. Thank you for Dr. Rosa-Liza, interesting projects. Thank you very much. Then we will move to the last. Yeah, thank you. Then we move to the last topic from UMP.
Okay. Can you hear my voice?
Yeah, can.
Okay. Now I would like to share first. Okay.
So pass it to you. Yeah.
Share tengok okey tak? Okey tak?
Boleh.
Okay, alright.
Yeah, loud and clear. Can hear you, no issue.
Okay.
Yeah. Go ahead. Thank you.
Audio. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. Thank you, Dr. Lee and all participants. Alright, this is my topic for today, yang phone for environmental safety and monitoring. Okay, actually, this is our co-inventors, okay, Prof. Madya, Syaiful Nizam, and engineers and also chemists. And actually, this product had been patented, okay, under 3 patent, right? Okay, two of it is already implemented. Okay, this is the product background. Okay, e-phone is actually named from the. Actually, we started from identifying agar wood. Okay, normally these people from East Asia, okay, from Arabs, and they use agar wood very we call very obsessed in agar wood, so they need to test whether the grade is a high grade or low grade. So normally sniffers who expert in these matters in agar wood need experience 20 to 30 years. However, if we rely only on human sniffers or expert, so after somehow this will be the expert or maybe the health to the expert will degrade. Okay. This is the significance of having electronic device. And phone is coming from Arabs. So nose is actually eNose. eNose is the common name used in this technology, but I just rename it. Brand name is e-phone to attract Arabs. Right. This is how the function of the e-phone. Now we have two products. One is portable, and the second one is wall mounted. Okay. Okay. Odor detection actually need 3 in our theory. We need 3 experts or 3 elements, which is from the first one. We need to identify the odor, which is we need human experts in specific odor. But for example, in agar wood, or in environmental, we need expert who works in environment. Okay, and then second one, we need to validate the identification of the odor using chemistry analysis, which is GCMS or headspace or what we call SPME, to validate the compound that contribute to the odorous to the odor profile. And then lastly, all those human identification and then the compound from the chemist will be complemented with electronic nose, which actually we need to establish the library. When we have the library, or in chemistry we call marker compound, but in electronic we call it library, we store in the device, then we have the memory of the odor profile. So this is how it works. Okay. State of the arts, the methods. Okay. If I'm talking about eNose concept, we cannot run from compare with biological nose, either human biological nose or animal. Okay, because this is how the invention of the eNose. I think in 1990s. I think it's around 1990s. Okay, we compare with the biological nose. For example, in here we have 4 sections. Comparably, we have receptors for biological nose, and for eNose, we have sensor arrays. Okay, sensor arrays. You can put any numbers. Yeah, you can put any numbers of sensor array. Okay, 4, 5, some use 32, and even 60. And I heard one of the researchers used about 100 of sensor array only to get the pattern. But for us, we use the minimum sensor array. Then when this nose or electronic nose receive input about the odor, we have another one which is olfactory bulb for biological nose, and for e-nose or e-phone we use signal pre-processing. We need to pre-process the signal to see the pattern, to establish the pattern, and then that one we will store the pattern or the profile into the. If for biological nose we use it will store in brain, and then for electronic nose store into the computer or into the CPU or called it memory. And then lastly, this is the test. The last stage, either biological nose or human or electronic nose can recognize the odor profile from unknown source. Okay, this is what we do. The same concept with biological nose. Some did ask me either this nose, phone can detect any odor. Yes, but we need to train. Same with the biological nose. If there is no memory, there is no learning in the brain, then of course a human as well cannot recognize. Once they are learned or they are teach from baby and young age until the adult, so they will become clever or intelligent. That's what we call intelligent. So this is the brain that I'm talking about, is the CBR. This is the uniqueness of this product, which is case-based reasoning. You can do, and you can use any artificial intelligence like ANN, fuzzy, whatever. But at the end, we need to see how the memory that we use, that one we are going to store into the CPU or computer, must be minimum and sufficient. We are talking about memory. For example, we are talking about deep learning. That's why they use the cloud, right, to store the whatever features, behavior of human. So we need a large storage. But for the phone, we use minimum memory. At least certain libraries can be stored without using cloud. Okay, so this is how sensor development. We need to acquire the data, pre-process the data, then develop the odor profile, and then use the AI, which is CBR. Okay, and then we measure the performance, evaluate, and optimize until we get the significant features. Okay. Among of the novelty of the and benefit in this phone, this is actually scientifically validated database. Use the human experts, sniffers, and also the chemists. Then we apply case-based reasoning, and actually this product is developed by UMP from our library, the whole bulk. The whole unit from AI, and also we for WM 1.0 is actually wall mounted, is actually specifically designed for IoT. Right. And then we have portable one. Okay, can bring to any source for environment, for example. Okay, outdoor base and cost quite a low cost. Right, this is the comparison estimated price that we already listed in UMP price. If you can browse to the UMP, so it's actually around 32K, and other INOS available in market around maybe like talking about 40, 50. This is the comparison is not much different from others. Okay, and actually this e-phone is a platform technology you can use either in environment, in agriculture, in whatever field. But currently we are actively use this e-phone for environment. I will tell later regarding the application. Okay, this is the business model that we try to commercial this product. Normally we do a service. Then we did rental previously. In this year we did rental, and sales is going to be maybe this year, but mostly we do services. Services meaning consult what they need to solve. Then this is how the best way Malaysian product to be promoted and to be commercialized. This is among of application that we use. Okay, the top one is of course environmental. Okay, and then oil and gas, health and safety, agriculture, food quality as well. Okay, right. This is a potential market that we have. Now we are working also with Lembaga Cocoa, okay, to try to detect the best grade of cocoa bean, cocoa seed, cocoa liquor. Okay, then we are working on that. We are working on that. Going to present to them maybe this month or next month. Okay. And also we go into automotive. Okay, automotive like Proton, Podua, just our client. All right. The best thing in this product, okay, we already did consultancy services at the Samdabi Oil in Thailand. Okay, this actually Samdabi Oil Thailand have had a problem where they produce actually Samdabi Oil produce soybean oil. So the odor vaporized from their factory to community. Before they run the factory, actually there are development, okay, domestic housing. Okay, so this factory is told to be not to be open. After that, Sandabi bought this factory, so they open like 24/7, and complaint coming from the community. So they try to solve this about 3 to 4 years until they meet us. We try to solve this in 2019, and then we can identify the main source that complained by the customers using our detection using this e-phone. We try to locate the e-phone at several locations to find the similarity, which is complained by the community at the housing, domestic housing. And then lastly, we solved that one. Previously, last 2 to 3 years, this factory is asked to work to limit the operation hours. And now currently, Alhamdulillah, they can operate the factory 24/7, 24/7 because they already they solve that problem before use our method. This e-phone, they are going to develop new plant, but by detection using this e-phone, they can reduce the cost just by go to certain plant that contribute to the odor. This is how we detect, and inshallah, if COVID-19 is the pandemic is okay, we are going to install the e-phone there, maybe the end of this year or early of next year, okay, in Thailand. Then we also collaborate with Subsea. Subsea is actually the ventilator who do consultation or selling the ventilator to ventilate the odor in internal building, but sometimes they cannot locate where the source of the odor. So they use our experts. Okay, for example, this is in medical lab, and below is the automotive factory somewhere in Pekan. I cannot mention. It's confidential. But both problems already solved using the odor detection, using our method, e-phone, because our uniqueness is to find the similarity. Odor maybe normally some will ask whether they have a standard of number of measurement, whatever, but actually this is ENOS or e-phone is a non-parametric instrument where it based on human sniffers. Sometimes by using standard instrument like ppm based whatever, they can have the numbers, but they cannot sense the odor. This is the how ENOS or e-phone solve or complement the instrument that cannot be detected. They cannot detect the odor. So we also do this is Ajmal. We went to India, Assam, 2019 as well. This is the GM. Okay, the expert, 30 years expert also there. So we test the result, and sometimes the expert also confused the grade of the agar wood when we presented to their boss, because human have some weakness in detecting odor. Maybe because device or ENOS, if we do all the processes, all the procedure scientifically, then ENOS cannot. I mean, ENOS will reveal the true data, the true result. They cannot, like human, sometimes affected by by foods they eat, by feeling that they feel, and other variable. Okay, other variable. Okay, and then with Sandabi oil, this is to detect coconut oil and the quality of coconut oil, fish flesh with unimas, unimas, find the ikan yang dibela dengan yang tak dibela. Ni ikan tak silap saya ikan, I think what type of fish? Shark fish, I think. So we detect this. Okay, detect the one, and okay, we have some memorandum of agreement with a company. Okay, and okay, this is the environment that okay, to use we use at landfill, at factory, and currently we collect the data about 6 to 8 months at somewhere station in UNP, one of the station, which is the STP, sewage treatment plant. Okay, we collect the data. Currently we are collecting, and then one of the river water station. Okay, to find put the baseline of the library to see how many changes from the baseline to what is happening in the river. Okay, so you can monitor 24 hours. Okay, sometimes I go at night, at lunch, at daytime. So there's a changes. Okay, you don't know what is the source of what is why the odor is different, but maybe from the source, right? From the source, the pollution of the river, give effect the variance of the odor. Okay, this is the version what called young phone P1.0. Okay, in young phone WM 1.0. P1.0 is handheld, but for WM 1.0 is actually you can put it. It's already IoT, but need to be improvised. But still, we can collect data right now, minimum. Okay, we do the IoT. And this product has been used in several companies, rental, service, whatever. Okay, and this is the basic price, estimated price. And for monthly rental and service, price is negotiable. This is okay. And studies from raw water based ammonia, and the first thing that we did for e-unfold is actually detecting ammonia from the water surface. Okay, this is some achievement we did. Tech planter demo 2019, and then we have we won Emerging Innovator Award, Malaysian Commercialization Year 2019, and also now lastly in MTE in 2021. Collaboration and industrial partners, the environment one, SPAN, Suruhanjaya Perkhidmatan Air, and then UMP Technology, UMP Consultation, and many others. Okay, thank you for your kind attention. Okay,
Yeah, thank you. Thank you, Associate Professor. Prof, very interesting topics. Now I have a question from the participants. I combine it to one. Sensitivity and accuracy. Can you answer this? Sensitivity and accuracy.
Okay, sensitivity and accuracy more than 0.9 or more than 90%. Okay, more than 90%. Okay.
Okay, thank you.
Okay.
Any more questions from the participants here?
Yeah, Dr. Lee and Dr. How about incorporating this into a drone, like for more difficult area and whatnot? So apart from portable, are you planning to go into more difficult pipeline or something and use a drone?
Yeah, we also you are thinking about that, but there is some limitation, which is we need to get a minimum. I mean, you are talking about drone, then drone, we need to talk about load, right? Maximum load, whatever. So for e-unphone, we need to reduce the weight. This is the limitation. Still can be developed, but we need to think about load. Okay, for example, drone has its load and also power, right? Battery. This is self battery operated, so can do. But if the power can be integrated with the drone, then should be fine. There is light to incorporate e-unphone with the drone. Inshallah.
Okay.
There is a way. There is a way.
Thank you.
Okay.
Okay, thank you. Any more questions? Because now it's 10:35, we are going to have a break in between before the next session start at 11 o'clock. Last question. Anyone? Okay, so if no question, then we'll see you again. Thank you again, Prof. And
Thank you.
See you all again at 11 o'clock for the next topic.
Okay.
Thank you. See you again
See you.
for our break. Yes.
Thank you. Amirul put the holding video, interlude video.
offer conducive learning and training environments. Our facilities and laboratories are equipped with some of the latest machines and simulation equipment to create a seamless transition from classroom to job. KISMEC offers a wide range of Industry 4.0 programs, such as Industrial Internet of Things IIoT, Smart Sensor Technology, Cybersecurity, Implementation of Industrial Automation, Cloud Computing, Data Analytics, Autonomous Robot, Factory Automation Configuration.
When I first heard about IoT technology, I still have a cloud in my mind. From there, I'm learning the concept of IoT, where it is a vast domain and it is an integration of existing technologies. For me, it is new experience where I can gain a new knowledge and IoT technology, especially on Bosch XDK sensor, which I believe everyone have already aware of this brand.
Our programs have brought priceless contribution to many organizations and human capital.
As the chairman of KISMEC, I look forward to embrace potential partnership with SMEs and multinational companies. In this globally competitive market, Malaysian companies should strive to be more operational efficient, promote automation and digitalization. Hence, Industry 4.0 is no longer an option. KISMEC is well equipped with the latest equipment and know-how, which can help you to implement Industry 4.0. We look forward to working with you.
We are Industry 4.0 ready. Connect with us today.
BT is championing the initiative in Industry 4.0 to enhance the competitiveness of the automotive industry. Design capabilities are a must for all industry players. The Mine Design Center is a key strategic initiative. This design center will empower all stakeholders, reduce development costs, and improve quality within the automotive OEMs and vendors.
Mari Additive Manufacturing Technology Center, MAMTech, is a new state-of-the-art center of excellence for additive manufacturing, developed by Mari to enhance the capabilities of local automotive suppliers in research and development of new parts and components for next-generation vehicles, as stipulated in the National Automotive Policy 2020. Mumtech is a comprehensive end-to-end online additive manufacturing service platform for automotive suppliers and the public to access a wide range of services from design optimization, simulation and validation, 3D scanning, reverse engineering, and post-processing. Mumtech can 3D print any design size and shape through an easy, fast, and secure platform without any manufacturing limitations. To begin, clients can access the Mumtech platform by going to www.mumtech.com.my. Clients can upload or drag and drop any 3D model file format. Clients can customize the printing parameters to obtain the desired results and get instant quotations right from the dashboard. Specialists at Mumtech will process the 3D model using finite element analysis to ensure only high-quality products will be 3D printed to meet the design requirements. The fresh 3D printed part is then taken out and submerged in an ultrasonic washing tank with isopropyl alcohol to remove its support structures. Next, a UV oven will cure the 3D printed part until it reaches its maximum mechanical properties before moving to painting and coating for surface treatment. The printed products will then be securely packed and shipped to the clients. The 3D printed part will be safely delivered right to the client's doorstep. Hear what some of our clients have to say about Mumtech.
I'm thankful to Mari for developing Mentec program. This is a very benefit for us engineers to stay update with the current engineering technologies. And the workflow for engineering analysis and the design optimization is very easy to understand.
We are lucky to use the top of software which is Katia, Materialize, and Shining 3D.
Provide this result in terms of high accuracy and of the surface finish. Basically, it expedites the process of
Start your additive manufacturing experience with us. Sign up for a free account at www.mumtech.com.my.
The digitalization of design is inevitable. Digital design strategies are now a basic requirement to remain competitive. It optimizes cost, maximizes function, and significantly reduces lead times. For many, technology may be a daunting prospect. It is for this very reason MASEC is the solution. MASEC was established to allow lowering the barrier to entry for digital design technology to be adopted by all. It is equipped with letter CAE solutions and high-performance hardware to become a design validation hub to enhance Malaysian design and inculcate high-value design capabilities. MASEC will accelerate Industry 4.0 technology adoption in advanced manufacturing, especially in the mobility sector. Its location is strategic as it is within Malaysia's hub for digital design and development. The collaboration between government, OEM, suppliers, and academia allows component manufacturers to enhance participation in the upstream processes of product development. MASEC elevates the supplier's capabilities to be able to not only design advanced products, but also the tooling and process design. MASEC will be a game changer for the mobility sector towards the improved designs and creating a high value added job and products. MASEC, the gateway to advancing simulation.
Jack it up.
Our world is transforming, going through a revolution that would significantly change the way we live. The fourth industrial revolution is at full speed, and this revolution allows for endless creation and innovation. Are you ready to take on this revolution? Kismek, since its inception in 1993, is a leader in TVET and human capital development. We are also internationally accredited and globally recognized as an Industry 4.0 training provider. In July 2017, Kismek was accredited as a Center of Excellence in Technology COE for national empowerment in certification and training for next-generation workers, NextGen Industry 4.0. Here is our roadmap of Industry 4.0. We are here to be your partner in this challenging yet exciting era of Industry 4.0.
We focus on technical and vocational education training, or TVET, and strive to deliver the best in Industry 4.0 training, which means progressing with time and technologies. Kismet has invested in new training equipment and machineries such as APAS Collaborative Robot, Bosch Didactic Workbench, Festo, MPS I 4.0, IoT Gateway, Bosch Smart Sensor, and Smart CCTV. We have upgraded our trainer skills and our center certification. Currently, our trainers have been certified as Malaysian Meister Trainer from Aachen, Germany, and Bosch trained the trainer in Basic Automation Industry 4. To complement industrial requirements, we shall continuously develop new training programs.
With strategic partnerships and collaboration across the globe, Kismek offers a wide range of training programs conducted by our very own highly qualified trainers in various fields of expertise. We continuously strive to be the preferred training partner by developing new training programs and upskilling of our certified trainers. Kismek's trainers are certified and experts in their respective fields upon completion of their training obtained locally and overseas. Vocational training officers and HRDF certified trainers, Malaysian Meister trainers, Bosch Basic Automation I 4.0 Master trainers. At Kismek, we offer conducive learning and training environments. Our facilities and laboratories are equipped with some of the latest machines and simulation equipment, to create a seamless transition from classroom to job. KISMEC offers a wide range of Industry 4.0 programs, such as Industrial Internet of Things IIoT, Smart Sensor Technology, Cybersecurity, Implementation of Industrial Automation, Cloud Computing, Data Analytics, Autonomous Robot, Factory Automation Configuration.
When I first heard about IoT technology, I still have a cloud in my mind. From there, I'm learning the concept of IoT, where it is a vast domain and it is an integration of existing technologies. For me, it is new experience where I can gain a new knowledge and IoT technology, especially on Bosch XDK sensor, which I believe everyone have already aware of this brand.
Our programs have brought priceless contribution to many organizations and human capital.
As the chairman of KISMEC, I look forward to embrace potential partnership with SMEs and multinational companies. In this globally competitive market, Malaysian companies should strive to be more operationally efficient, promote automation and digitalization. Hence, Industry 4.0 is no longer an option. KISMEC is well equipped with the latest equipment and know-how, which can help you to implement Industry 4.0. We look forward to working with you.
We are Industry 4.0 ready. Connect with us today.
Amirul, let's disable the video. Okay, over to you, Dr. Lee.
Yeah. So welcome back again for this session number 5. We will continue with next few topics here from IUC, UM, and UTM. So 11 EM from IUC represented by me. The topic is called Individualized Manufacturing Solution with Rami 4.0 Architecture. So I would like to share my slide. Can see the slide? Okay. Everyone can see?
Yes, good, Prof.
Okay, thank you. So today's topics here is individualized manufacturing solution with Rami 4.0 architecture. Now, why individualized manufacturing is very important? Actually, individualized manufacturing is the next 5 to 10 years issue topics. In 2014, Coca-Cola actually start the individualized bottle campaign. And you can see from the sales, you can see that the sales increased by 2%. Meaning that individual, everyone wants something different. Now, in order to achieve this individualized solution, you need to have a holistic integration. Meaning that you need to gather a lot of data in real-time basis. So individualized solution actually is a challenge is a challenge for Industry 4.0 to get the holistic integration, to get all the data into it. Now, the first thing here you need to do here is the vertical integration. Now, this vertical integration actually is talking about manufacturing automation, meaning that you integrate the shop floor to the top floor, and manufacturing operation data in real time will vertically up to the top floor, which is your enterprise resource planning, or we call it business operation management. Now, vertical integration is not enough to achieve this individualized manufacturing. You need horizontal integration, which is talking about supply chain integration, meaning that talking about value chain integration from your raw material to the manufacturer, and then you distribute, and then users using it. Okay, so now for this holistic integration, you need to have a platform to integrate this vertically and horizontally. Actually, we built a digital platform for this integration, holistic integration. We call it manufacturing change management, MCM. Okay. Now, this holistic integration, actually, we follow the German reference architecture. We call it German call it the reference architecture model industry 4.0, or they call it RAMI 4.0 by Germany in 2013. Okay. Now, in this diagram look very simple, but it has 3 axes over here. The first one here is called manufacturing operation, and from the product, field devices, control device, station, work center, enterprise, connected world. Actually, the SCADA, MES, ERP, and apps connected world actually is in the vertical integration, including the robotics. So many of the technology enabler, 11 pillar in Industry 4.0 fall onto this vertical integration for automation purpose. So this is actually IR 3.0. Completely vertical integrated is IR 3.0, because the model is origin from the Purdue University. They call it Terra model. Actually, they has an IEC standard for this purpose. Okay, so this is IR 3.0. Now, in IR 4.0, you need 2 more axes here. According to Germany, they define, because Industry 4.0 defined by Germany, okay, in 4th Industrial Revolution. So Industry 4.0 actually focus on manufacturing. So you need to have 1 more axis here. They call it horizontal integration. This one is for business operation. Actually, this is integrate the horizontally your value chain from the raw material until the user one, until the waste recycling. Okay, so you can see this is called architecture layer. And it has a 1, 2, 3, 4, 6 layer. Compared to the hierarchy level got 7. Okay, actually Industrial 4.0 RAMI in 2 more axes, 2 more level, product and a connected world, to make this para model complete for Industrial 4.0. Okay, so horizontal integration, you have a 6 layer here, and you start from asset until the business here. Of course, I'm not going to detail one. Okay. Now, but the term asset layer is very important. Asset actually is something that can create value. Create value, additional value for the business. Meaning that the data that you collect, you can transform them into information and create value for it, and we can name that as asset. Okay. Now, this is second axis in the RAMI 4. The next one here is a life cycle value stream. This is actually talking about product tracking. So this is very important for this RFID and all this code, all this product tracking, GPS, and all this is all under this life cycle value streams. Okay, so if you have a 3 axis, now if you want to have an Industrial 4.0 architect, if you want to be a Industrial 4.0 architect, I'm not talking about technologies. Of course, you can be a IoT technologies. You can have additive manufacturing technologies. You can have cybersecurity technologies based on the 11 pillar in Industrial 4.0. It's a specific for only a technology enabler. But if you want to talk about Industrial 4.0 architecture, meaning that how are you going to give consultancy, how do you give industry advice on to how implement this Industrial 4.0? Technology is one part, but you must be a very good architect. Okay. Now, the framework of the architect actually is a RAMI 4.0. Now, in order to visualize the RAMI 4.0, you need to build one line. for you to, for people to, to understand, because talking is quite difficult. So that's why we build a line. We call it OMIS line, OMIS production line. We call it one bit manufacturing through individualization solution. Okay, so you can see we link the supplier, manufacturer, retailer, end user using apps. We call it personalized e-commerce app to order a very customized mixed juice from a calamansi or ginger. So you can define your juice ratio you want, sweetness you want, the volume, the bottle size, and even bottle label. You can print your own family photo. Okay, so we personalize it, or we call it individualize it through these 6 processes mixed juice production line in TAUC. Okay, and then of course, bottling system, you need to manage their asset, because assets is data sovereignty, and sometimes data is very confidential. So you need to have a bottling system to manage their metadata before they can exchange data between these different stakeholders in the value chain. Okay. Now, you can see from here, this actually demonstrates the vertical and horizontal integration. And this is architecture and the industrial partner together with TAUC to build this line. Actually, we have around 12 to 13 of industry. And you can see from each layer and each level, there are different companies to participate in, to contribute their solution and complete this RAMI 4.0. Okay, so I show you this is how the OMIS line look like in TAUC. And you have 6 processes here: packaging process, loading first, and then you have a filling, capping, printing, unloading, and also you have a packaging processes. Actually, this whole process here is no one in between one, because the PEC is apps order the juice by the the customer, and they're using the apps to set all the juice they want, and then after that you will come to here. This line will run by itself, and then you will produce, and then you will print your deliver address on the packaging, and after that you will pack into a delivery bag automatically. Okay, so actually the people in between all normal. Okay, direct from the customer. See, this is actually one of the C2B model, customer to business model, because a lot of e-commerce now is a B2C, mass production in the manufacturing. So you mass produce, because our manufacturing has a minimum quantity order. You cannot produce one. Okay, so you have to ask customer to buy whatever you make. So it's B2C in e-commerce. So the only thing that you can do is compete pricing, because everyone sell the same thing. So whoever cheaper one will sell better. Okay, or you find the manufacturer have a better quality one or different design. That is a business model for B2C. Yeah, in nowadays. But for the coming years, then you are going to have a C2B, meaning that customer define the value what they want. Then manufacturer will produce for them, even one piece. Okay, that is the future. Actually, nowadays already in practice, like car, like all these very expensive shoe, they all custom actually individualize it. Okay, by a very big company. Now this I show you how the line look like. Yeah, this how the line look like. Okay, so this how the time is the reverse. Upside down, call it upside down. Okay, so you can see on top there is the labeling, and the bottom upside down already. This is the conveyor, and you can see they have RFID tracking here to track the products, individual products. And then this is the filling process. So it's successfully demonstrate how the individualized production is going to work. Okay, now then what OMIS line can contribute to to the SME in this industry 4.0. Okay, so OMIS line actually you can contribute to. The first one here is to create a digital twin for learning to foster many industry 4.0 architect. Okay, so we stress on the architect. Now, if you want to train this industrial 4.0 architect, you need to buy equipment, buy industrial 4.0 physical line, production line. Now, let's say you have 8 learning center. You need to buy 8 unit of this very expensive industrial 4.0 line, very expensive one. So now you have 4 challenges. You have a very high investment, definitely, because everyone buy single unit. And you may not fully utilize it because each center here may not have a student to learn. And sometimes they sit over there, and then you depreciate from year to year. This is one challenge. The other one is high maintenance costs. Actually, Malaysians had a grant to buy this line, but they have no fund for maintenance. So they need to look for maintenance. So a lot of projects abandoned because no maintenance costs. So you imagine that you have 8 sites to maintain, the cost is very high. Last one here is you have a different learning content. Because different people build different content, so you learn differently. So you do not have a center place to refine and strengthen the content for producing industrial 4.0 architecture. So the best way actually is building the digital twin. Okay, modular, we call it modular model industrial 4.0 digital factory. Now, how does it work? Actually, you can see you have a hardware content. Hardware content actually is a learning hardware content unit, and you only need to be in one place. You can fix it in one place here, and then you create your software content. Yeah, software content meaning that you link to the software to the hardware content. Actually, you link the digital side to the physical side, and they are twin. Meaning that whatever that you look at your monitor, actually is the same as what you see in the digital factory. Okay, so everyone will book their calendar. So this week I'm doing training. Next week you're going to do training, and this hardware content, digital factory will run 365 days, fully occupied one. Okay, maintenance. So they can see their advantages is over again the traditional one. You can maximize the lowest investment. Maximize lowest investment, meaning you only buy one, but you maximize it, because you can let it run every day. Okay, and of course you fully utilize the line, and you have a very low maintenance cost because you only need the one technical assistant to maintain other than you need 8 of them. And then of course standard learning content, because they all learn, we build this content based on the one physical line. Okay, now then you say, okay, fine, this is a trend in the next few years? You look at this research in digital twin for learning. This is actually from 2020 last year. Actually, this is a learn in China. Okay, they want to use digital twin to do mass production. Okay, for their industrial 4.0 talent in China. Now, how to build this industrial 4.0 architect? Of course, we need to base on the RAMI 4.0 I mentioned to you just now. So you've got 3 axes over here. Okay, so the first axis here is a hierarchy level. Okay, now we look at the architecture layer, AL layer. We name it as AL level. Architecture layer 1 to layer 6 here. These are all the topics that you need to learn in AL1 to AL6. Okay, and then you need to learn the hierarchy level here, from level 1 to level 7. This is a topic that you need to learn from HL1 to HL7. And then finally, you need to learn how to do product management in manufacturing industry. How do you trace the products using VSM or using the PLM, you need to learn. So once you completed all these 14 modules for 3 axes in RAMI 4.0, you can call them as a industrial 4.0 architect. And then they can study individual technologies in more deeper, because they got the overall picture, they got big picture. They got the architect, they got a very high architect level picture. Then they know, then you want to focus in, for example, like robotics, or for example, IoT. Then you can go deep. So you have a wider, you have a deeper. Then technology will come into play as a technology specific in certain area. Okay, so this is actually the starting. Now, the second thing that the OMIS line can contribute on actually is to produce the digital solution. Okay, so we solve the first one is talent. Actually, we solve the first one. They call it, first one actually is to solve talent shortage. Talent shortage. The second one actually to overcome the SME digital solution. They don't have a digital solution. Of course, you can buy, you got money, you can buy, but you're going to have an issue of affordability and scalability later on. Okay, so now in currently, what the Industrial Forward Intervention Fund, actually they build POC. Many of them generally they ask them to do digitization, right? And then they can ask them to purchase the enterprise resource planning, and then they do the integration. They pass the data into the ERP selective data, not all selective data, because ERP is not to real-time storage all this sensor data one. So they need to selectively. Then they store inside the database of their own system built for the company. Let's say, for example, like you do IoT, you build one database. And then people come do another IoT, build another database. So you've got many database. That's its challenges because you don't have a center places. Okay, so scalability is the issue. You can produce a proof of concept, no issue one. How about 10 machine, 20 machine, 30 machine, 2 factory, 3 factory, 4 factory, whole supply chain? How are you going to scale? That's why a lot of SME, they reluctant to move forward. Although they get the grant, they get a matching grant maximum only 500K, 250. So if they go into it, they need to sustain it from year to year. So you must create value for the company one. Okay, so we need to moving forward. You need to have one more layer. We call digitalization one. So you need a solution to help them to do this manufacturing operation and manage all the data from the shop floor before they pass it to the ERP or even accounting information system. Okay, and then of course you need to have some HMI template because a lot of machines here is industrial 3.0 or even 2.0. So they need to do this evolution. Okay, from the digital from the physical to the digital, and it's not finished. You need one more layer. This is called digital transformation layer. Data you collected through the digitalization, you need to do this analytic and intelligent at that layer. Then you can create value because digital transformation is a business model. You transform from one business model to the other business model. It's a whole. It's a whole change of the company direction and model that they use. So you need to use all this data collected and processed in the digitalization layer and produce value for them. For example, like the lead time improvement, labor efficiency, relate to the humans. All this relate the manufacturing processes to the business operation. You need to do this, study. Then only they can improve the yield, they can improve the lead time by how many percent, the labor efficiency, machine effectiveness, all this. Not only OEE, because OEE is only for process monitoring, not for business improvement one. Okay, so you need one more layer for this. Now, of course, SME, they are constrained in their budget, okay, and they are spending, and also sustainability. So for scaling, so we need to have our own homegrown solution in Malaysia. For example, like V1 is making a very good dashboard display. Okay, and IoT data collection, data machine integration, very successful, very good systems here. And you need to have Octane as a platform for them to create systems, and then they can create this MES for them to run their business manufacturing operation. Okay, so and then we need to have someone to do process intelligence. For example, like from IIUM, Advanced Technology Sdn Bhd, one of their spin or company to do this process intelligence, so that they can get all the data from the database. Okay, now this is how the digital solution for Industrial 4 digital factory look like. So this is Industrial 3.0. Here you have your SQL, ERP, enterprise builder. This actually is a Malaysian blend. Yeah, so you can see that they don't integrate together one. Okay, then machine is machine, top floor and top floor. So the first thing here you need to do is integration. And then followed by the system creation to create a lot of system for digitalization. For quality, for inventory, for maintenance, for production, you need systems. Even for servicing, even for the labor cost management, all these you need systems. Okay, and then later on you need to do dashboard, report, analytic, or intelligence. And all these data here, you need to collect it into one place here. They call it enterprise asset space here. You gather all the data, and then you can start to do management services in process intelligence. So this is actually a very systematic and structured way how you can guide the industry from the beginning until the end. It's a journey in digital transformation. Okay. Now, how this architecture look like? EAS architecture look like? So you have a layer called data sources. Okay, so this you need to do integration. You need to define asset. This is an axis number 2 in RAME 4.0 asset. Define asset. So we only select certain asset, certain data which is great value for the company. We need as asset. So you need to collect them in the real time and collect all. Then after that, you need to provide them some module so that they can do, they can create asset. they want, they can create system they want, they can do machine integration they want. Okay, so that this is no code, low code or no code. Meaning that is by setting only. You don't need to hire any SI to do programming anymore. So it's very flexible. Okay, so now, but it is not enough because you provide them digitalization modules, it's just operation. There's no intelligence involved. Okay, no intelligence. So this digitalization module create even more data than compared to the data from the shop floor. All this data here will be collected in the EAS, and then you need to do process intelligence. Okay, so you do this process intelligence, you create another asset. Then you can store back the asset back to the EAS, and you can create a dashboard for you to display whatever you want as a CEO dashboard, not the production dashboard, CEO or MD dashboard, which is relate between the process into the business. Okay, so you can relate all these parameters. Now, how about the framework research in digital factory framework? Actually, this one is China is very aggressive, but they proposed the framework in this year. Okay, this year, early this year, framework proposed only, framework in 2021. Okay, actually, this is a Hangzhou furniture industry. Hangzhou furniture, they help this Hangzhou furniture to do the digital framework. Now, it looks like this way. Very complicated, but you don't need to worry. Actually, there are 3 levels. They say they got 3 levels. Now, if you have an integrated manufacturing processes, you do vertically and horizontally, you get all this. Now, definitely you're going to have a data level one. This data level is all the data that you collect from different various data sources here. Now, if your big company is fine, but your SME, you create so many databases, you create these databases, then you will create a lot of data acquisition issue. Okay, so this is the data level. After you organize the data, then you go to the information layer level over here. And then finally, you have a knowledge level. So this framework proposed by them in China early this year. Now, you look at here, then you can see we map one by one. Now, you can see the data level actually is an enterprise access space. Okay, I told you just now, you can create a lot of systems here, you can do all integration. Actually, this is the EAS for this data level. And then when you go up to the information level to transform the data into information, this is called, actually we call it manufacturing chain management. And we built one platform for this purpose, we call it Optic. Okay, finally, this is a knowledge level. You need AI. Okay, so you utilize the process information, and then you can create a lot of assets. Outcome as asset, outcome of the analytic intelligence as asset in the EAS, and then you can use the dashboard module to create dashboard you want and compare to all the process asset you have in the manufacturing shop floor. Actually, this process here is very valuable. You look at Germany, the most valuable star company called Celonis. Celonis, C-E-L-O-N-I-S, Celonis. Celonis is they raised the funding $1 billion US. $1 billion. The company worth $10 billion. Early just 2 months ago. Okay, they are doing process intelligence exactly in the knowledge level. They integrate the data sources. From the SAP, from this Google Suite and all these. They integrate them all together, and they can get the data from all these platform. Basically in an enterprise resource planning platform, and then they can do this intelligence. They call it execution management system. New term, they call execution management system by Celonis, and the company worth $10 billion US. Okay, so I finished. Thank you. Okay, so I get back to the floor. Open for the floor for questioning.
Yeah, Dr. Lee, thank you for sharing, Fauzan. I put a question there. Apart from the German REMI standard, any other known international standard on Industry 4.0 that you will come across?
Actually, there are different standards. From China, China is called IMSA, Intelligent Manufacturing System Architect. This IMSA actually is following the RAMI 4.0, and this IIC is a international Internet of Things consortium. They also have their own standards, but they are focusing on the distributed sensor network. So they are following the physical, cyber physical system framework to build this structure. So for manufacturing, Rami is the most suitable one.
Okay.
Thank you.
Because under Malaysia, we have a standard development that we are trying to do with Standards Malaysia. So we need standards so that we can establish or refer to international standard for a Malaysian standard.
Yeah, actually we have. Actually, I'm the members of the working group in DSM. Yeah, now they are now one of the come out a standard for, they call it smart manufacturing. Okay, they call it smart manufacturing. Actually, they follow the China smart manufacturing in China. They want to adopt from China because China is a manufacturing country, a big one. Okay. So the reference is back to China, but China back to our Army 4.0. The origin is still from Germany.
Okay. Maybe we take other questions.
Yeah.
Any other question from anyone? You can put it in the chat or you can ask verbally.
Yeah.
You have about another 2-3 minutes.
Actually, the work that we do is to solve the two major challenges in SMSM Malaysia. One is the talent. Yeah, one is talent in mass production. The other one is actually digital solution from local suitable for SMSME.
So maybe apart from OMIS and Octane, what are other things that you see focusing on Industry 4.0?
Actually, we also focusing on the business layer for agriculture one. We call it algorithm. So we create a platform for for value chain integration of agriculture. Rami business layer. They need data from lower layer one for this integration. Okay, so this is one. We also work in IoT also. IoT, actually we work in industry. Many of the projects from industry from Advantech use their product to make this smart agriculture.
There's a question from Dr. Yong. How your system is practical for SME?
Yeah, that is a good question. So how practical? First thing here is affordability. The first question here is affordability. Okay, meaning because SME they have limited capital and limited investment and resources also limited. We cannot build or you cannot introduce a very expensive system for them to use. Of course, they can start, no problem, but that's the issue. Yeah, so we need to taking care of practicality in terms of investment. One. Second, we need to create value. We need to help them to increase their profit. Because our data collected, of course, you can do a lot of IoT, all this IoT in the shop floor. But ultimately, it's still profit. So you cannot ask them to stop at the IoT from physical to digital, stop there, you cannot, because they need to sustain this digitization one from year to year. They need to put in money. So you need to help them to continue the journey until at the end they can get the data to help them to increase the profit. So you need to paint this picture for them. This is second. Third, the third one will be the scalability. Scalability meaning when they move from IR 3.0 to IR 4.0, even to IR 5.0, how do they need to scale accordingly? So we need to tell them how to scale. You cannot change system from one IR 3.0 to 4 using one system, IR 5 and then 4 to 5 using one system. So you cannot. So scalability. So it has to be very practical one. And we don't bombard them too many modules because ERP or MES or MOM they are for large enterprises. A lot of modules they don't use, and you also fix. And when you fix, meaning they need to do a lot of customization because SME their manufacturing operation is very variant, a lot of variant one. So it's hard for them to fix one off-the-shelf software to target for all the manufacturing industry sector. So that's why not practical one. So we need to have a system which is very practical and able to adapt this variant to create different kind of system they want. So this is practicality. Thank you.
Okay.
So the question here is, manufacturing has a lot of asset with a different protocol or engine generation. How the framework address the differences? Okay, that actually is this asset here, we are talking about two different type asset. One asset here is in accounting. Accounting we call asset. Is something that a company invest money in, and you have a depreciation. We call asset. Like machine is an asset. Okay, so now in Industrial 4.0, Rami 4.0, when we talk about asset, is covering everything. IP, your drawing, even your process, even source, even your machine, whatever, as long as they can create value for the company, they are all termed as asset. So this asset in Rami 4.0 actually wider scope compared to the asset in accounting book. Okay, so now, then how are you going to do this generation protocol and generation? That is the question. So meaning that you need to be scalable. You need to a system that you must be able to sustain the practicality from moving along this journey. Okay, so you need to create a system here for you to track all these changes of the asset, depreciation. You can create a system to do this monitoring one. Okay, so protocol. Now, if you want to do different systems, then you have protocol issue because different system built by different SI or different company. So integration is challenges. So for SMA, SMB, they no need so complicated integration or so many systems. If you have only one, then it will be very practical. So you only have an EAC for them to keep all the data and create all systems they want. So it's very practical. Thank you. The framework is for that purpose. Actually.
Yeah, thank you. I think we have to move on, Dr. Lee.
Okay, so thank you very much for everyone question. So we move to the next topics by the by Dr. Hari Krishnan Ramya. Topic is CR, remote asset monitoring with RFID in the GPS system. Yeah. So yours, pass to you.
Yeah, thank you and good morning all.
Yeah, morning.
Yeah, so how do I share the slides?
You go to the top there, you can look at the share,
It's disabled, the share.
Disabled. Okay.
Yes.
Organizer side need to share. There's a share button.
What is the name you're using? Dr. Hari, is it?
You mean the
Krishnan, okay, Hari
slides?
Krishnan. Okay, make you a co-host. See if you can share now. Can you share now? Because you're a co-host, you have a capability to share.
No, the button is still disabled.
Okay, did you send the slide to Dr. Yong? We can play it out from here.
Yeah, I did share it in the Google Drive, but it was the PDF copy.
It's okay. You have videos?
Yes, I do have videos.
Okay. Dr. Yong, maybe he can send to you or he can send to me, then I can play it out from my end. I'm not sure why your sharing is not able.
Or maybe
So
I should.
Can
I try leaving and coming back?
Yeah, quickly, maybe.
Yeah.
Okay.
Yeah, the button is still disabled for me.
I think there's some setting at your PC because you're not using the client version. Send it over to me. I'll play it for you.
Okay. Should I email to you?
Yeah, email to me. Because it has a video, right? If not, we can use the PDF.
Yeah, true.
Yeah, just send to me. I'll play it for you. maybe while waiting, Hari, maybe you want to introduce the CRI4 verbally, then I'll get it prepared.
Yeah. So good morning, all. I'm from the Center of Research in Industry 4.0, University Malaya. Okay. So the Center of Research in Industry, University Malaya, was established quite new, about like 3 or 2 years ago, and we basically concentrate on supporting the industry and also developing a know-how talent in the aspect of IR 4.0. We also look into the aspect of continuous support towards the SMEs in order to upgrade the facility available in line to IR 4.0. And we also facilitate in the product development in line of IR 4.0 for both MNCs and SMEs. So the center is being headed by myself, Hari Krishnan. I'm from the Faculty of Engineering, Department of Electrical Engineering, University Malaya. So, and then we are basically placed under the administration of University Malaya, where we encapsulate the various faculty, not only the engineering, Faculty of Computer Science, Faculty of Business, Faculty of Science, and also Faculty of Engineering. So we cater for the needs of industry in all aspects, ranging from the training, the product development, facility upgrade, and also consultation. We also provide awareness to the industry on the need and also the urgency of IR 4.0. Fauzan is taking a long time because my file is big, about 300
Okay,
mega.
I got your PDF. Maybe I start with the PDF first, huh?
Yeah, it's taking a long time.
Okay, just a minute. Your PDF. I found your PDF in the Google Drive. I'll bring up the PDF later on. We sort out your video. Okay.
Yeah, sure, no problem. Thank you very much.
Okay, view full screen. Okay. Sharing screen shortly. Okay, share. Okay. Okay, you can see the screen, right? Okay, just go ahead now.
I can see. Yeah, so basically this is the introduction I was supposed to start off with about the Center of Industrial Research 4.0 in University Malaya. It's a collaborative center established in University Malaya between various faculties and the facilities and the research centers available in University Malaya in order to facilitate the collaboration between the industry, be it the SMEs and MNCs, and also the university. So today we are going to look into some of the projects, a brief overview of the projects that have been done by the Center of IR 4.0. Some of the projects are given to you as a brief introduction, as the project is still ongoing and there is some issues of IP filing as well. So can you go to the next slide? This is my brief biography of my background. Next, please. So the industrial evolution or the revolution of industry have been progressing from 1.0, 2.0, 3.0, and finally we are here at 4.0, where the growth of industrial revolution of 4.0 is seen to be in an exponential manner. So we should be aware that many of the industry, be the MNC or the SMEs, especially the SMEs, are still struggling at the range of 2.0 and 3.0. And we have identified that many SMEs have difficulty in absorbing themselves into 4.0 due to the lack of facility and also the know-how knowledge in adapting the industry of 4.0. We have been facilitating the industry, especially the SMEs, in the aspect of upgrading themselves in the context of digitization so that they can actually adapt automation eventually in order to increase the productivity of their output. We have also looked into SMEs in order to encourage product development at the end product rather than providing design services activity as their output of the company alone. Next. So basically, what we are looking at as a problem statement is basically the disadvantage the companies are facing in lacking in speed, communication, connectivity, system integration, and intelligence, especially in the manufacturing environment. So our aim is to develop an industrial 4.0 platform, especially for the supply chain management, with collaboration of research centers, industries, and also the expertise from University Malaya altogether. We are in the quest of addressing the challenges that's mentioned above in the context of the communication, connectivity, and system integration, and strengthen the digital connectivity between the industrial, education, and also through efforts such as training of resources. Next. So the proposed solution that's available in CRI 4.0 that we have made possible with the collaboration with MNCs and OSMEs, basically the IoT-enabled supply chain management system. This system is deployed in CRI 4.0, and the facility serves as a prototype in training and also upskilling the resources from the MNCs and also the SMEs around. So the prototype is well equipped with IoT edge computing facilities in order to monitor and also to access remotely the output of the supply chain management output. And we have also looked into the health conditioning of the supply chain management system through the deployment of efficient IoT devices. At the center of CRI 4.0, many of these IoT solutions are basically done from scratch in order to facilitate the adaptability to the need of the environment that is targeted for. We are also enabling autonomous operation and decision-making capability through the integration of IoT devices and also integrating it with the remote monitoring system that we develop for the need of the company on need-by-need basis. So we are also working together with the experts in the Faculty of Computer Science on enabling data encryption and big data analytics in the supply chain management system on the company's need basis as well. One such product is a recent product or project being delivered to Texas Instruments, Malacca, where data analytics was employed in order to adopt data encryption in the quest of digitization in cloud computing. So the dedicated work in CRI 4.0, as I told you before, we are basically find expertise in customizing IoT devices for specific equipment in the supply chain or out of the supply chain, such as in the logistic environment itself. The system eventually will be connected to a cloud computing through data analytics and also precision for the data analytics and precision decision making as well. So the security features is adapted to encryption, which is a continuous work at the facility. So at the end product, we will actually develop the dashboard and also the mobile app in order to enable the monitoring and also the control of the facilities in target here. Next. So this gives you a graphical user interface overview of the facilities, which is made available at CRI 4.0. The video in the next slide will actually give you the current setup of the facility facility at CRI 4.0. As you can see here, we basically make use of the robotic arm in order to facilitate the prototype of the supply chain management system. We have a single lane supply chain management system with high vision camera system and control through a PLC controller, which is remotely accessible to our remote monitoring system. We perform various algorithm adaptation in the image processing aspect in order to increase the decision-making capability of the high resolution vision camera system at the supply management system. And we also basically enable IoT-based feedback system in order to control the PLC controller in adapting automation by the end user. We have deployed IoT monitoring system at the facility in order to monitor the health of the supply chain management system, such as the smart light control, smart air conditioning or heat ventilation and air conditioning monitoring system, smart temperature control system, and through also smart camera facility. We have yet to actually deploy the AGV system or the AYE system to integrate the logistics system with the smart manufacturing environment, which is placed in CRI 4.0. However, we are basically working on the logistics system, and we are filing an IP in order to enable intelligence in vertical logistic management system. This is enabled through the RFID detection at the end of this supply chain management system, and also through the continuous monitoring of the weight detection from the logistics system supplied or basically contributed by POSAT. So we are working towards in developing the GUI and also the dashboard in order to enable automation and intelligence in the logistics system, where we are about to file an IP with POSAT on this project. Next. So this is basically the video, Fauzan. So is it possible to play it?
No, I think it's PDF. Maybe later we'll try to get it.
Yeah,
because I didn't receive your file, so maybe it's too large. Can you also send it through the WhatsApp? Because sometimes email filters large slides. Or if you have a video you send to me, I'll play it later.
Or perhaps, do you have a Google Drive? I can drop it there. I think it's even faster.
Yeah, the same Google Drive, you can drop the video or the slide. We can, Dr. Yong or me can help you to bring it up.
Okay, I actually lost the Google Drive link.
Okay. Dr. Yong, maybe assist him with the Google Drive link. Do you want to talk through the slide or you want to get the video?
No, I can talk through the slide as well, but the video will be good in order to visualize the current setup at the CRI 4.0.
Okay, you continue with the slide at the same time deposit. If someone of your staff can deposit, we can bring it up.
Sure. Okay, so so the video here will actually give you a very brief description of the facilities available at CRI 4.0, which basically is 6-axis vacuum sucker based robot system and the prototype of the manufacturing line. And we have also showed about the dashboard system that we have developed for the vertical logistic management system. It was contributed by POSAT. We have enabled intelligence and decision-making capability at the dashboard system through remote monitoring and also detection by RFID basically tagging. Okay, so that is basically the inside of the video that would be shown by you. So what we are doing here in CRI 4.0, the added value of research towards the factory processes that's available today, what we are expert in and we have experience in at CRI 4.0 is basically in the setup of smart and autonomous digital production lab for the real use case, like in the industrial production. So our facility here is particularly catered towards the electronics or the E&E industry, where we basically work a lot on the end product of a PCB solution. So we are also looking into stepping up the cyber physical system to IR 4.0 by connecting the cloud services and data analytics. This is basically done in collaboration with our partners in the Faculty of Computer Science, where the expertise is basically derived from their research centers over there. So we're equipping the complete factory setup with IoT sensor. This is basically our main expertise lies on in IoT sensors to get maximum data to be fed to the artificial intelligence big data system. This customization will upgrade the overall system to the status of autonomous cyber physical system. So these are basically some of the work expertise that CRI 4.0 can basically embark on, as we have good experience and good capability in terms of the delivery of the end product in the aspect which is highlighted here. Next. So the research application and the benefits out of the projects being developed in CRI 4.0, not to include, and it's basically, we see that there's a lot of reduced costs in terms of the process, the optimization of the resources that's available, time efficiency, risk reduction and prediction, especially in the manufacturing of the E&E product, make the industry more market competitive. And basically, we are able to improve the process control and the management system altogether. Next. So these are basically some of our collaborative partners where we have embarked an MOA and MOE bid, and we have also some active project going on with these collaborative partners. So not to include the government agencies, we have industries such as Omron, Bossard, we have Asascom, we have Sime Darby and Texas Instrument in the context as well. Next. So this is our IP, which we are basically progressing currently with COSAT in order to develop the RFID-based smart storage system with real-time monitoring. So this system have been embarked and also is in the due diligence of the completion of the process, where the IP filing is still underway. Next. So our expertise revolves in these four aspects in Internet of Things: the deployment of sensors, IoT sensors in particular, the artificial intelligence, embarking of the artificial intelligence at the decision making end of the smart manufacturing system, and also some aspect of the robotic, including collaborative robotic techniques. Next. Next. So these are some of the potential area that CRI 4.0 are currently collaborating with the industries and also some of the research center. We are also we are looking into projects such as the smart recirculating aquaculture system, where basically aqua farming is enabled in urban environment through the deployment of continuous monitoring or remote monitoring of IoT devices. So this was basically embarked with an industry and also the research center from the Faculty of Science. So CRI 4.0 have basically deployed the IoT devices for urban aqua farming capability. So we are also working with the local SMEs in smart ambience control system for heat ventilation and air conditioning system for telecom towers. This is an ongoing project to upgrade the value added output of the SMEs from a design service provider to product development entity. So this project is still ongoing. The company is financing the project in order to basically facilitate the research activity or the development activity together with the purchase of the necessary equipment for the product integration. So we have also embarked with MNC OSRAM in order to provide the solution on real-time asset monitoring and tracking system. So the initial proposal was on basically a LoRaWAN solution, but eventually downgraded to Bluetooth technology due to the constraint of cost. So this is basically an ongoing project as well with the MNCs. Okay, so we are also working in development of geolocation-based item monitoring system using IoT location-based sensor. This is a self-exploratory project within the CIR environment itself. Within the environment, we have also working with RFID stabilizer for 4D axis automatic stand. This project is churned out of the desired vertical logistics system management, which was in collaborative with POSA. So the integration of RFID scanner with PLC for smart supply management system was also done within the environment of CRI 4.0 in the effort to facilitate the dashboard and also the GUI development for continuous monitoring of the logistics system. We have also worked with Sime Darby in smart precision farming, where basically we developed a prototype of basically IoT-based or wireless sensor network-based continuous monitoring of the ambient environment in the lab facility. This is a short-term project. So most of the projects under CRI 4.0 can be categorized in the context of short-term and long-term. The short-term project will be usually deployed to our undergraduate students through the continuous program of the projects, which includes the final year project itself. Whereas the long-term project is basically undertaken through the employment of research officers through a period of 18 months to about 36 months to the maximum. Okay. We have also looked into a smart energy management system. This is a app-based GUI developed in a short-term project, and an SMT PCB inspection system with robotic arm, which is also an output of a short-term project under CRI 4.0. Next.
Dr. Krishnan, Hari Krishnan, you have 5 more minutes.
Yeah, go ahead. Next.
Yeah, 5 more minutes because time constraint.
So these are the basically the projects that have been implemented in the environment of CRI 4.0, where you can see the snapshot of the prototype being basically presented here. Next. So in continuous to the previous slides, these are the snapshot of the projects being deployed in the environment of CRI 4.0. For the projects that have been explaining on the aspect of the short-term involvement within the environment of the university and the students itself. Next. So this is the smart ambience control system for heat, ventilation, and air conditioning system for telecommunication tower, where we have taken up this project as a product development for an SME, basically upgrading the facility from a service provider entity. Next. Next. So the remote access monitoring system, the problem statement is basically in the context of the continuous access movement. This project is embarked with an MNC, which is OSRAM, and also the time consumption in order to detect the movement of the asset, and also the cost consumption in the case that the asset is basically is needed to be replaced. Next. So in this project, we actually developed algorithm and also the necessary facility in order to optimize the placement of the anchors in the environment and the dedicated environment planning of the factory, where the environment planning of the factory in this context is OSRAM. So the optimization of the placement of the anchor through the Bluetooth technology provides us the ability to do localization in order to continuously monitor and detect the movement of the asset. So this project is currently ongoing, okay, and we have basically been completing this project to about 50% already. Next. So this is actually another video where basically the algorithm will actually visualize the movement of the asset and how the anchors are placed in an optimized environment in the existence of the blockers in order to detect continuously the movement of the asset. So I guess the video couldn't be played here as this is a PDF file. So the algorithm is developed in order to optimize and also the use of a minimum number of anchors in order to realize this remote asset monitoring system. Next. That basically wraps up the projects being done under CRI 4.0, which includes the remote asset monitoring system, many short-term and long-term projects, and also the smart ambience control system, which is embarked with an SMEs. One of our pride and joy is basically the deployment of intelligence and also in continuous monitoring of the vertical logistics system from basically the prototype deployed from POSAP. So if you're able to view the video that is embedded into the slides, it will actually give you a very good overview of the system, the dashboard system being developed in order to continuously monitor the logistic environment. That's all from CRI 4.0. Thank you for your attention.
Dr. Hari, I have a suggestion. You send me the video, I will upload to the YouTube that we created for this event, and I'll put the link to the chat members. Those after this event, they can grab the video from the YouTube.
Okay, I will do that.
You pass to me, I will upload to the YouTube.
Okay, thank you. So I'll open it for question and answers.
Yeah, thank you for Dr. Hari Krishnan's Ramya presentation. Any questions from the floor? I have one question for Dr. Hari Krishnan. Regarding the data storage, you do on-premise and also the cloud.
Can you repeat it? I couldn't get it.
Data storage, your IoT sensor data storage. How do you manage your data?
We do it from the cloud computing facility that we have rented out.
Thank you. Any more questions from the floor, from the participants?
I think we run out of time. Like I put the YouTube channel in the link. So later on after this event, we will upload the YouTube from UM, then you guys can take a look.
Okay.
Okay, thank you.
Okay, thank you. So the next
thank you.
Thank you.
Yeah, thank you, Dr. Hari. The next topic will be from University Technical Malaysia Malacca. So I pass it to you. You can share your slide now. Thank you.
Test.
Yeah, can see your slide. Can hear you also. You can proceed.
My name is Dr. Muhammad Najib. I'm from Penyelaras Pendidikan from Fakulti Kejuruteraan Pembuatan, University Technical Malaysia Melaka. Okay, basically for today's session, I will talk about the simulation optimization as tools for Industrial 4.0. Okay, my background is I have did my mechanical engineering in Germany. Back then they call it as a diploma in, and then I further my mechatronic degree in Aachen University, and then I completed my PhD in mechanical in USM. Okay. Thanks. Okay. First of all, I would like to introduce the research group in FKP UTEM. FKP stands for Fakulti Kejuruteraan Pembuatan, where there are 5 research groups you have, namely Sustainable Responsive Manufacturing, and then Integrated Design and Process Research Group, Smart Materials, Human-Machine Interaction, and then lastly the Smart Factory System. Overall, in university there is a lot more, but I will only only introduce these 5 research groups under the Fakulti Kejuruteraan Pembuatan here. And the niche of the research group is the smart system and the innovative design, where the research focus is focusing on the design, materials, manufacturing, and operation management. For the manufacturing, it can be not only the traditional one, it's the future manufacturing system, future process, and precision, automation, and so on. So I will directly go to the focus of the today's session, which is I want to explain the optimization simulation tools for Industrial 4.0 using some case study that we have in FKP UTEM. Rather than I explain for a lot of examples, so I will only focusing on one of the examples. Okay, because only have 15 minutes session. So basically, the outline will be what is the Industrial 4.0 in terms of simulation. Then what are these examples that the software that we use here in the FKP UTEM. Then I give some case study about the robotic structure optimization and the conclusion. Basically, if you see the pillars of the 4th Industrial Revolution, I'm sure there's many experts here. Before this, I already explained some about the big data analytics, autonomous robots, and so on. That is already covered, and IoT. There is, I'm sure the speakers before this speak about this technology. Okay, and we heard, but as you see, there are 11 technologies pillars, which is the simulation is included. In some examples, in recent publication, they have reduced the pillars. But from my opinions, the 11 and the number of pillars should be stick. The more pillars, the more that area that we support to the 4th Industrial Revolution is much better. For this one, the simulation can contribute to the, for example, to accelerated technologies. Okay, so accelerated technologies, modeling, and advanced analysis. Yes, it has been started by many companies, but still a lot more companies haven't used the simulation as their tools. So this is, I think, that is the area that the companies can focusing on and on. Basically, what is the simulation tools in FKP that we use here? We use it to simulate simulation in the field of products, for example, new products and a new mechanism design. And then other than that, the simulation is also used to the manufacturing process. I mean, for example, to find what is the optimized material flow for that layout and so on. And then what is the best layout to improve the layout and so on. And then the simulation is also used for the product testing reliability. I mean, yes, the reliability testing normally is being done by experimental approach, but that one is can also be done by simulation. And then other than that, we also expose our students, especially recently due to COVID-19. So we use the simulation for the student laboratory. Okay. Okay. So what is forcing is the CAE simulation, where we use the from the virtual parts. Either we reconstruct our the parts by the 3D scanning. Okay, and then we do the 3D scanning, and then we draw it virtually, and then we optimize the parts, and then we improve the parts by optimization, and then we use that optimization. Or this drawing can also be drawn, for example, from a figure, for example, from a figure. There's some method that you can do other than 3D scanning from figure, and lastly, you can do, for example, by using the sensors to measure what is that is what we use, the laser scanner. Okay, and then we use the from that we improve the product and the process through the through the simulation optimization, and then we do the material analysis and also the reliability testing. Okay, and then from the results we used for in the post-processing. Okay.
We have 5 more minutes, Doctor.
5 more minutes. All right, I'll be quick. All right. The software tools that we use here, we have the ANSYS version. The advantage of this ANSYS version is it can be installed and can be used to any user, and it's valid for 1 year. Okay, so valid for 1 year. So and also it can that's why we use it for our laboratory training, because we replicate our lab, some of our lab, and then we let our students do the simulation and so on, because the ANSYS give this advantage and can solve a lot of problems. And this is basically the 5 steps. So I go directly to the examples. For example, this is the examples that I have created using the student software robots, where this is the crawl bots. And then we are conducted the optimization study to optimize this robot structure. All right. For example, we optimize the linkage length optimization. Okay, the linkage length optimization means, for example, we set that the distance between the front gap between the front leg and the end leg has to be at certain distance, and what is the length that we should put in the operate value so that we have that results. So that is the optimization. This kind of optimizations can be solved using the actually this design. This is DOE. This is DOE that is embedded in the ANSYS software. Okay, that is the advantage. That's why we are now promoting this kind of software, because sometimes they use this DOE using the different software, but in this ANSYS there has the optimization, and the DOE is inside this software. So then, of course, there are a lot more steps to get to these results, but so the time constraint I cannot explain step by step, but this is what is possible that can be achieved. And then secondly is the optimization through the fundamental frequency. Why they do? Why we want to optimize based on fundamental frequency? And the first figure you see is 140 hertz. For example, from this 140 hertz, we optimize this structure. On the right figure, you see 164. The frequency is higher. When we optimize this structure, it's not only we reduce the mass, the structure, the fundamental frequency is also higher. What it means, the natural frequency occurred at higher frequency, right? So that is means by the optimization based on this fundamental frequency or fundamental frequency. So we optimize, not only we save reduce the mass, but also the vibration occur at higher frequency. Okay, that is also can be achieved using this. Other than that, is, for example, the site support optimization here. From the normal supports here, we run a topology optimization, and then we run the topology optimization, put some constraint on the right hand side here. You can see what are the mesh that we can, for example, here we set 50% mass reduction. So based on the same constraint and the computer can run and then suggest which part that should be removed and which part should be maintained. So this is very useful. For example, if you want to optimize your structure to make it this robot move faster, and then we use less material and so on. And also it's very useful for the 3D printing technology. Okay, and lastly, this is the another part. This is an apart from the robots that I want to improve. I just want to show you the upper figure and the lower figure is slightly different because it depends on the setting of. For example, you can see we want at the bottom of the parts here, we don't want to remove it. So that's why then we can run it, and then the computer will suggest what is the structure that we should have, so on. Okay. Okay, this the conclusion. Okay, it's very fast, right? Right. Because the conclusion of the case study here, you can see there are two conclusions. The response surface optimization and this topology optimization can be conducted specifically in ANSYS. Yes, we have different software, but I take this one as an example because this can be installed and can be used for anyone that would like to learn. You can. We are also targeting even not only the undergraduate student. We hope that this software can be used to high school students, for the high school students, because because it can be installed and can be used for free for 1 year. And for example, you can see at that figure, the colorful figure here is determine the parameter correlation. It means when you change some parameter, from the width and height, what is the biggest parameter that influence the structure the most, and that kind of correlation, that which one have a biggest output and so on. Everything can be done in the computer simulation. Even the material, if you know the materials data, so we can vary that is the material data, and then we can see what is the results that we have. Okay, this kind of simulation, I think, is very useful, and not only for the industry, but for students as well, especially for the research students and for the one who are in research, and for the one who are like to create some innovation design. So this is very useful tools. And yes, thank you. That's all from me. So there is my WhatsApp number. So any inquiry, workshop, or collaborations, you can send to my emails and WhatsApp. There's also the link of form here, because I'm also organizing like a training for the software that I mentioned. For those who are interested, then can fill in that forms. Is the price I is about 80 ringgit for 2 days. It's very cheap. Very cheap. Because I've attended last training in Germany. I paid for 3,000 euro for 1 week. So because this part of I try to. I know there's a lot of company, lot of research students. They're struggling. They're struggling because I have some. Last time I also struggling. So this is kind of platform. I'm maybe interested can fill in. And
Thank you, Doctor.
Okay.
Thank you, Doctor.
Any questions? Then can ask me or can ask Prof. Zam later.
Yeah, thank you, Doctor. Dr. Muhammad Najib?
Yes,
Yeah. Any question from the floor? Because of the time constraint, so we cannot take too many questions.
Maybe we proceed with the Prof. Summary first, lah. Then we
Okay,
ask question together.
Yeah. So yours, Professor Dr. Zamri, you can share your slide.
Thank you. Thank you, Mr. Chairman.
You have 15 minutes. Thank you. Your voice is not.
Prof, your connection is quite bad, Prof.
Hear me?
No,
Yeah,
it's
connection.
breaking. Breaking. Yeah, it's breaking a lot.
Really?
Breaking a lot.
I'm breaking. Because I'm not in office, but still okay. I think it's still not.
Yeah, still breaking.
It's quite bad actually.
Still breaking.
We can't even get one word clearly from you.
Because I can hear the presentation of the Najib quite well. My line will be okay.
Maybe your download speed is okay. Your upload speed is no good. Can we do something? Dr. Yong. Dr. Yong?
Yes.
Yeah, if you can take the slide, maybe the Prof. Zamri can call in by the phone. Yeah, we can hear you.
Yeah, okay, now I changed to my hotspot. Okay. Sorry for the problems. I will try to share my slides now.
Okay, yeah, go ahead.
Is it on?
Yeah, can hear clearly. Slide not in yet.
Okay, already click sharing. It's not sharing, I don't know why. Still not yet. I can't see my slide anyway. Not yet, what's wrong?
You share? Do you share?
Normally
Do you
should be
share?
okay.
You share?
Yeah, I already shared it. I tried sharing the screen and also sharing the file. Check first.
Prof, let me share for you.
Okay, please.
Hang on, it's coming up.
Can you see can you see the slide now?
Not yet.
No, I can see my slide.
I think, Prof, since you have a bandwidth issue, let Dr. Yong share the slide. You can just voice over. Dr. Yong, you grab the slide. Huh? Yeah, okay.
Yeah, I'm hoping.
Okay, Prof. Zamri, I think you just voice over because we'll save some bandwidth.
Can see?
Yeah, your slide is coming up, but Prof. Zamri, are you still in the call?
Okay. Okay.
Yeah, I can see now.
You just remote control me.
Yeah, but where is Prof. Zamri?
Prof, like that.
Prof. Zamri, are you still in the call? Okay, we have to wait for Prof. Zamri to come back. Maybe he got disconnected. He's disconnected, right?
Yeah, seem not in.
Yeah. So let's give it a few minutes and see whether he can come up.
Dr. Najib can maybe can communicate with him.
Oh, Dr. Yong, just talk to him, call him and see whether he could connect back.
Okay.
Sorry, everyone. We need to bring back Prof. Zamri first before we can continue. Thank you for your patience.
I thought you are out. Okay. Okay, sure. Thank you. Thank you. Yeah, he is trying to connect.
Okay. So meanwhile, if there's question for Dr. Najib, can also put in the chat. Can take the question temporarily while waiting for Prof. And Dr. Najib, your link for training, maybe send it to us. We will help you to promote to other users because when you put it in the slide mode, people cannot get the URL.
Oh, can I put in the chat box?
Yeah, you can put in the chat box now. We also help you to promote outside this event.
Oh, thank you.
So your simulation is basically mechanical and thermal stress?
Yes, basically it's mechanical, yes, structural and flow. So the flow will include the thermal and the flow process. But normally, for example, one of my project last time I did with the Fraunhofer Institute. Sometimes we are not doing the optimization because the optimization required a lot more of computing time. But the normal simulation also we want to know what is, for example, last time we do that the fluid jet polishing process and also the reflow soldering in the oven, and we model and to see what the effect of the temperature on the overall SMT on our PCB and so on. But doing the optimization here, I think is much more interesting because, for example, those who want to optimize, they have their existing structure, and they are interested to do the optimization. A lot of products they manufactured without doing the optimization. So the window for the optimization is I think is quite large. If they can do the optimization, it depends to the company either they want to proceed it or not. But because yes, because
we have Prof. Zamri back, I believe. Prof. Zamri, can you hear us?
Has he joined?
Yeah, look like there's a name there, Prof. Zamri.
I'm not sure. Actually, we are online from the same institution. I'm not sure why their signal is different from my office. I'm not sure why. Because we are online from same institution. Why?
Yeah, supposed to be same bandwidth. Yeah.
Yes, that's.
Prof. Zamri, can you hear us? We can see you in the WebEx. Can you turn on the microphone?
Prof have an audio issue.
Oh. I mean, worst come to worst, he can call in, using the telephone line, then we can play the slide.
What number?
I think if you go to meeting info, you click meeting info, there is a global call-in number.
Meeting info, okay.
Yeah, he can use the phone to call in, then we can register his voice, the slide we can play. Yeah, I can see this number here. There's a 03 number. Malaysia toll and Malaysia toll 2.
This one?
You see?
514, bukan kan?
Macam mana?
251814011617.
That one is the access code for this meeting.
Okay.
The earlier one, the top one is the phone number. The bottom one is the access code for this meeting. So he can join with a voice without internet.
Number I have is that is the.
Okay, if you can't, we can schedule later, but just try. Sorry, attendees, we will try to get Prof on the phone. If you fail to get him, then we need to reschedule his portion to tomorrow, on Wednesday. Okay, so give us another 5 minutes, then we try.
Hello.
Yeah.
This is Nan here. I think I got his number on the other.
Jack it up.
Like you speak over the WhatsApp. I share the screen already, so hang on, I put up.
Oh, he's gonna talk through your phone.
Yeah, can it? Yeah, okay, Prof, start.
Okay, thanks for this one.
Yeah, okay.
Oh boy.
No problem. Yeah, it is audible. Pause one.
Pardon me?
Can manage Just go
Okay.
on.
Yeah, Prof, I share the screen. Can you now is on the first screen? Can you see?
On WhatsApp.
You talk over the WhatsApp now. No, you talk over the phone now. Then I navigate the slide. Next. Yes.
Okay. You can hear me, right?
Yes.
My apology for there's something wrong in the PC and it's working both at the same time. Okay, I will try to make very, very short since we are running out of time. Basically, the idea here is my work is it's related to machining. Machining is manipulation process. The idea is to come up with a controller. It's a motion controller. My work is basically focused on the slide maybe.
It's slide? Yeah, it's moved.
That slide.
Yeah.
That slide. So the work is focusing on the slide and the slide way. Basically, it's a motion controller to control the relative motion between the bandwidth table, where we put our raw material and the speed. I think it's the replace. Next slide, please.
Yeah.
In machine tools, the idea here is that we would like to have as accurate and as precise product as possible. So the main aim is the tracking error basically to be as low as possible. And ideal is to be at 0. Next slide, please. Okay, so this is basically my work, developing a controller. The basic idea is that it's a feedback loop. And only for the motion, let's go to the table positioning. And next slide. Slide number 6 now. In any machining process, there are disturbance forces which act upon the driveways, the guideways, and also the signal. And typically what it does is that it's cutting force because of the interaction between the tool and the material. It creates the additional force that can exert the unnecessary vibration to the position cable. And also the friction force which comes from the guideways itself. So we need to be able to compensate these forces in order to have a good machining process which reduce error. So that is basically the idea of the work, is to come up with an intelligent control system which is the development of machine tools to develop machines, for example, which cater for the driving force and also the friction force. So I will start off with very quickly here on the friction behavior. Page 9, please. Friction is basically it's part of the machine. If people who work in machine, they would know that during the reverse velocity motion, whereby the table change direction. For example, from the left, it turns to the right, where we have a sinusoidal signal. Mostly we have what we call a quadrant gauge. You can look the figure on the bottom right. So there's a gauge at the quadrants for the 4 quadrants, and whenever we do a circle. So that that's identified the existence of friction. So that has to be removed. So we're going to remove it through a control design approach. So basically, the first work part is basically on the friction modeling. If we can know the friction model, could feed forward into the control algorithm, and we could eliminate it directly without the necessity of having post machining operation, for example, deburring and things like that. And this is some of the actual experimental results we obtained using some of the different approaches. The leftmost part is the one without any compensation. We can see that there is amplification, a lot of error, especially at the quadrant pitch, error. But if we proceed with more advanced pitch model and so forth, all those errors are being removed, and we are talking about the micro level here. So it removes until very close to like a maximum of 3 micron. So that is very, very precise. And this is also slide number 12. It's also previously was slide number 10, number 11, number 12. So in here also we can look at the error for both X and Y axis. We're talking about the simple motion. You can see that again. The glitches and errors are removed. So we are again talking about the level of micron. And the other part is cutting force. This is slide number 13. An example of cutting force is the one shown on the middle part below. So if you look carefully, if you perform a spectrum analysis on the cutting force, we could see that it consists of harmonic peak. So whenever there is a spindle, something rotating mechanism acting on the workpiece, and then it will generate harmonic frequencies. So we know that even though we could compensate cutting force because we need cutting force to cut the material, but we could eliminate some of the higher peak, which would induce vibration. So with this idea, we could, the next slide 14 please, we could, 14 and 15, we could reduce control approach whereby we could, since we know the type of input disturbance that comes into the machine, we could eliminate those peak by using an observer design, by using a disturbance force observer with an inverse model base, and also we could also include some friction model here in order to compensate both at the same time the friction force and also the cutting force. So this can in fact could be extended to any mechanism with a vibration impact due to rotating spindle. So again, the chart of page 16 shows clear removal of those peaks, meaning that if we see in actual practice, the vibration will be removed. So in fact, this technique could be used in any application. Vibration is just to remove the vibration, and as a result of that, we could increase the accuracy and the precision of the setup. And lastly, control strategy number 3 is by using a robust controller. This is based on any model. So a robust controller that is most commonly used is remote. However, most of the machine tools nowadays, they don't use this type of controller. They are using a basic PID controller. So again, this kind of a strategy, we could eliminate both the vibration and also friction altogether. But the only thing is that this is a bit more difficult controller to design. However, we have done this in our lab, and it can be done in actual machine development. And lastly, my slide number 19. This is an example whereby we have combined our controller design in the lab and simulating environment with Katia, whereby we submitted the drawing, which is basically an island. And then we managed to use our continuous controller design in the form of MC, cascade, and so forth. And we are able to compensate both the friction and the cutting force in order to get the precise motion and product. I think that's all very quickly overview of my work on the part of machining with regard to our intention to produce intelligent machine for machine application, especially in machining of parts and so back to you, Mr. Chairman. I'm sorry for again my apology for the inconvenient cause. It just happened in my laptop. So the network is not working both at the same time. Back to you. Thank you so much.
Thank you. Thank you, Prof.
Okay, thank you, Prof.
Over to Dr. Lee. I think we run out of time, plus we have a voice clarity issue. Maybe we take the question offline. Maybe we'll wrap up first.
Okay, so thank you. I mean, yeah. So,
So my apology again. Sorry.
Yeah, no problem. We will pass to you any question that out from the floor. Okay,
So generally, I feel university have a lot of work. The preview that we do in a 30 minutes or 1 hour is not sufficient. So later on, we will organize a little bit more detail by university. So for example, UTEM alone, maybe one day, TAR UC alone one day. So we can schedule it next year, more longer by university, because I think each university have more content than what we preview today. So I just suggest to the team and participant that stay tuned for us to organize it by university. Maybe UTEM, UTHM, UTM. Everybody has quite a bit of content on Industry 4.0. So they just show 1 or 2 examples today. So if the interest level is there, we can organize a more deeper conversation with each of the university later on. Over to you, Dr. Lee.
okay, so thank you very much for Thousand Nasir. So I think we end all the topics for today's session number 5. Altogether, 1, 2, 3, 4 from different universities. So hopefully everyone will be coming again for session 6 tomorrow.
Not tomorrow.
Wednesday. Yeah. So, thank you.
All right. Thank you, everyone. Have a rest of the day. Good. Thank you. Bye.
Thank you.
Well, thank you very much.
Okay, thank you. Bye.
Jack it up.